Welcome everyone. Today we're taking a break from Nim for Honor Engine and we're gonna try Naylib, which is Nim plus Raylib. So we're changing from massive engine doing complicated things to minimal game library. It's not even a framework. And yeah, let's see what happens. It should be simpler, right? So let me show you what this is going to be about. So first of all, for those who don't know, what is Raylib? Let's search for Raylib. Not Naylib, Raylib. Okay. So Raylib is a simple and easy to use library to enjoy video games programming. It's really popular. Originally for C/C++, but basically nearly every programming language has bindings for it. And yeah, it's just really basic. As basic as it can get, while being somewhat powerful, I'd say. Even won some awards and a bunch of other things. Supports multi-platform. C#, Go, Lua, Python, Rust, Zig, Odin, and Nim, and many others. Okay. And has a bunch of libraries for dealing with math, with abstracting away all the OpenGL stuff, or I believe Vulkan and DirectX as well. Deal with audio, with GUIs, with some resources and stuff. And I don't know, TV? Bunch of other technologies, This is just a lot, and it's a very loved project. So the thing is that for Nim, it's just called Naylib. And hello CPN, welcome back. How are you doing today? So the whole idea about Naylib is basically, it's a wrapper for Raylib, a library created for 2D and 3D games. The Nim API is designed to be user-friendly and easy to use. So we'll see to that. And yeah, it should be basically the same thing as just a Nim. CPN's doing good. Awesome. I'm doing pretty good myself too. Alrighty. So the plan for today is that when we look at Raylib, I know it's a bright screen, but that's a theme for Raylib. So what I would like to do is basically set up a basic application so that we can display a window and then go through examples. Because when we look at examples, there's a number of them, okay? And I don't know if these are all or not all, but there's plenty of them. So, we'll probably start with something like a basic window, and I will show congrats. Or then maybe we're gonna move some, at some point to the camera so that we can move around and whatnot. I believe zoom in and out, right? And all those basic things. I don't know how far we're gonna get. So I would like to go through some of those examples to start learning Raylib and how to use it from Nim. Because, again, I haven't used Raylib before, to be honest. But as from my peek, it should be relatively straightforward. Nothing crazy there. So, yeah, that's that. Let's just set the project up and try to deal with some examples. So the thing with examples is that, Naylib allows us to use Nim, but when it comes to examples, we've also provided some example code to help you get started. You can find it in the accompanying example repository. So when you look in there, turns out it contains Raylib examples ported to the Nim programming language. And it also includes some extra unique ones, like these, some fancy ones, okay? Even a whole game level or something. Don't know to what extent that actually works. But I just peeked through what examples are here, and turns out that, you know, in the core, whatever, there's some of the ones from here implemented. Like when we click core, there's a bit more here than it is in the ported examples, so we're probably gonna try to follow both or something. CPN says, I tried Raylib with Zig a while ago. It's awesome. So we're gonna see if it's awesome for me too. It's a little bit lower level than I'm used to, but at least it's not, you know, dealing with SDL and or just straight up OpenGL or something. All right, so let's set it up. I believe it's real simple because when we look here, installation, install Naylib, easily with nimble install Naylib. I believe that installs it globally. Not sure actually. And then make sure to install the required dependencies using your OS's native package manager. Don't know what that means. In this case, what required dependencies? And go to examples. And that's it. Huh. So, alternatives. Nim for on engine. There we go. When the new Godot 4 bindings will be released at some point, maybe they are already released, I would like to try that as well for the Nim language, because that will mean we can suddenly make some more serious games. So yeah, install it. So I'm gonna do it a little bit differently. I am going to create a new folder, Naylib, okay. And we're gonna make a new folder, stream1, okay. Let's go to the terminal. Make it extra large, and we're gonna do nimble in it, and we're gonna make it a binary. Initial version 0.1, sure. Package description, no need. License, whatever. MIT, sure. And lowest supported Nim version, let's do 2.08 because that's the latest release. And that's it. Sure. Should be done with the terminal. And let's just right click and open it with VS Code. Okay, so the first thing that we want to do is basically require the Naylib, right? So requires, already knows, Naylib. How? And what is the latest Naylib? Releases 5.1.4. Sure. 5.1.4. Okay. So now we can go to nimble install. And we should be able to do nimble run. Of course, we'll just get a hello world, right? Yeah, because the default thing is hello world. That's it. Spin is asking, how was my vacation? Actually pretty good. It was supposed to rain for all 3 days. It didn't rain at all. So somehow I'm still alive after all that sun. But yeah, great. Thank you for asking. Alrighty. So, okay. What do we do now? Yep, I agree. It was great. Alrighty. So we've got an installation. Also provided some example code to help you get started. You can find examples. Okay. So let's look at examples just so we have something to start with. I don't know, astar.nim. Let's just copy it all and see if it works. Okay, paste it, save it. That's some code, but not too bad. And let's run it. Nimble, run. Oh, it shows on the wrong screen. But there we go. It runs the search somehow. Restarting? I don't know what it does yet. But hey, it worked. That's great. Wow, it's really looking for something. I was looking for the corner. There we go. From corner to corner. Sure. So we've got the code that works. So I recall that Raylib had this basic window thing going, right? And I believe it was in core, an example. Basic window. There we go. So let's just copy the code and see what's in here so we can start understanding. Okay, save. Let's see if it runs. It runs. There we go. Perfect. Congrats, you created your first window. And not really yet, but let's start understanding it. So we import Raylib. That's obvious. Then we have section global variables definition. Okay. Screen width and screen height. Simple. Program main entry point. Okay, so we do proc main. Wow, that's it, okay? We initialize by doing init window, screen width and height, and I presume this is the title of the window. Set target FPS, set your game to run at 60 frames per second. Sure. Main game loop. It's literally a loop, so we make our own loop. Okay. And we have our update. So well, we're not doing anything. Then we're drawing, which is begin drawing. Clear background with Ray White. Draw text. Congrats. And this location of and size. Can I see? Oh, there we go. Draw text. Basically text. Oh, we're passing text as C strings. Okay. We can live with that. C string and nim string should be interchangeable, so that's good. Position X, position Y, font size, and color. Perfect. And then we've got end drawing, so we have this segment here. And after the loop finishes, somehow we do while not window should close. So this is a built-in helper to actually detect windows close. Button or escape key. Look at that. We don't have to do that ourselves. That's awesome. All right. And then we close window at the end. Close window and open GL context. And we just run the main function at the end. That's it. Okay, I can live with that. It's funny how we actually need to manually run the main function. And in C++, this would be run automatically for us, but here, hey, we can do whatever we want. Sure, so let's make it a little larger. 1920 by 1080. And let's make it the basic window. And what else can we change? Congrats, you created your first window. And make it 50 size. And this would be coordinates X and Y, so it's gonna be probably off to the left. Alright, let's see what happens if this still runs. For sure does. There we go. So I could do something not recommended, but sure, let's do var. Let's make it text position. We're just gonna make it position X will be 0, position Y will be 0. Or what was the Y? Y was 200. So let's keep it 200. And text position X and text position Y. I'm just trying out to make sure that few simple things still work. Okay, that's saved. I don't know why this is unhappy suddenly. Mismatch. Ah, it's expecting something else, something other than integer? What is it supposed to be? Expected either position or just int 32. I see. What was it? Dash I32? Yeah, that's how it was. Look at that. I'm starting to remember some of the nim stuff. Okay, and the last thing is that during update, because we don't want to change variables during the draw, preferably, I assume, we would just do text position x. We'll just increase it by 1. Okay, and let's see what happens. Let's see if the text actually moves. There we go, it moves. We've got our first animation. It's not greatest because we're doing it just at a frame rate, but in this case, you know, no big deal. Okay. It would be nice if I could just make Windows start up on this screen, but I don't think it's gonna be easy enough to do. Thank you, CPN. All right. I mean, this is simple. I already have many questions on how to hack things together, but let's look at some examples. I'm gonna leave this tab open here with Raylib examples. Let's just look at something that's in here. Let's click core because this sounds like, you know, the main simple ones. And we have ratings from 1 to 4 stars for the complexity. So let's look at 1. Basic screen manager. What's this? This example illustrates a very simple screen manager based on states machines. Okay. So I saw that it had something, wait 3 seconds, and then jumps to that. So looks like we have some definition of a logo, title, gameplay, and ending. 4 different states for the game screen. Okay. And program main entry point. We just have, again, dimensions and the window. And game screen, current screen is logo. So this is our start, right? To do initialize all required variables and load all required data here. Okay, sure. Then we have our frames counter and get our target FPS. So we still need to count them manually. Main game loop. So the same that we have, and during update we basically switch. So if it's logo, we count the frames, and if it's more than 120, which in this case will be 2 minutes, if it's larger, then we just switch to the next title. Sure. To the next screen. And then if we have title, we set those, if pressed, or is gesture detected, it will be gameplay. And then when we have gameplay, and if pressed enter or tapped, we go to ending. Okay. And at the end, we just do please enter to return to title screen. And this will just get us back to title. So we never go back to logo. Okay. So it's a very simple loop. And during drawing, we just, depending on the state, we just draw specific things, okay? Draw a rectangle. Is the rectangle like the whole background? Ah, so clear background is always to ray white, and then we just draw a rectangle over everything. Yeah, with screen width and screen height. That's simple. So you know what? Let's recreate that, but without looking into how it's recreated in Naylib examples. Let's see if our solution will be very similar to what they provided, if they even provide it. If yes, it will be interesting to learn why. So we can start with our, with thing that we already have. So what we'll want to define is to define a game screen enum, right? So we even do it here. Type game screen is enum, and something tells me AI will just do it for us. Okay, we don't even need the 0 here. It's by default starting from 0. Okay, that's good. So then, okay, I guess in C++ we can't use global variables and whatnot, so we need to have things contained within main. That makes sense as well. So what? We have screen width, screen height, all that fancy stuff. Sure. And we initialize the window. So we'll get there. But what else do we have? Current screen. So, So we either could do it here and make it global, or we could recreate what they have and make it within main. For now, I'll try to keep those new things here within main. So we initialize window, and only after that, when we succeeded, we're gonna make that, say that current screen is logo, okay? And we make it variable so that we can actually change it. Then we have our var frames counter, which will be 0, and this will count frames. Look at that, even comments. Love it. So there we go. Set desired frame rate. Set desired frame rate. Okay, let's actually set it here. Constant target frame rate will be 60. Okay, we'll be able to reuse it. So this is here. And after that, Windows should close, and we have our update. And during our update, instead of playing with this text position that I can just straight up get rid of, yeah, we basically do the switch. And in case of nim, instead of switch, we use case. Case current screen. Why do I have it capitalized? This one. Of logo. So when I have the logo, we want to basically increase the frames counter. I guess this is the only spot where the frame counter actually matters. Okay. Then we've got the, basically if frames counter is larger than target frame rate times 2. So 2 seconds. Then we're just gonna switch the current string to title. Okay, that's it. That's simple. And then we have off title. So in here is key pressed. Do I have it available? Is key, yeah, there we go, is key pressed. And we just give it keyboard key, which I guess will be key enter. And then we do or is gesture detected. Look at that, we have it all here. So if that's the case, we're gonna switch to gameplay. If I control save, no, undeclared identifier, key enter. Key enter. The keyboard key dot key enter. Enter. Okay, P. I guess something like this. Yeah, and here will be gesture dot tap. No, what is expecting? It's what the hell is it expecting? Or for some reason it's getting confused. If that's what we're missing. And now what can I control click? How do I get tap? Now it works, so I guess I could do this here as well. Okay, sure. We'll find documentation later. So then we have, if it's a gameplay, we should just do simply the same thing. If pressed enter or tap, we just switch to ending. And if we have ending, again, enter or tap to get back to title. Okay, so wow, we condensed that a little bit compared to C++. A little bit less of boilerplatey brackets and stuff, so that's pleasant. Okay, and then we have draw. So begin drawing. Clear background to ray white, sure. So I guess C++ wants everything screaming, while here we can just use nice camel case and whatnot. With first capitalized, is that Pascal case? I forgot my cases. So then instead of just doing draw text, we can do again another case. Current, depending on current screen. If it's logo, look at that. We can just reuse the variables, right? Draw text and draw text for 2 seconds. Oh, you could even add dynamic thing of how much time is left. And if it's title, we just do the other stuff. Yeah, so Pascal case is the one that begins with capital letter, while camel case is the one that begins with lowercase letter, I believe. Yeah, because you have camel has humps in the middle, while Pascal case, I started with Object Pascal. That was my first programming language. And yeah. Okay, so draw a rectangle. Yep, with height, green color, title screen, all that stuff. Sure. So I like how AI can already assume that, okay, that's how we're going to capitalize everything, and just goes for it. Yeah. Here we'll begin draw the background and draw the text and everything. Sure. So this is where order really matters. And the last one will be the ending. Again, just a bunch of screens. And we don't even need else anymore. A default is break, but sure, else discard. We could have that. We don't have to have that. And why we don't have to have that? Because if there was one extra option, compiler wouldn't let us compile. So that's the nice thing. And then drawing, and that's it. We already got everything going. Will that work? I mean, my instinct tells me this will work. Seconds, and went to that. I can click. I guess click is already a tab. Another click, and another click. Title, gameplay, ending. Title, gameplay, ending. And I can just do. Oh wow, this is not fast. With Enter is fast. Oh, I see. So single tap will switch to it, but when I'm clicking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it's not going fast. I guess it's being registered that, oh, this is not a tap, this is double tap or something else. Okay. Well, with space bars, I can do I mean enter keys. I can just go crazy. Cool. Very cool. So let's see if we have that example created on the Naylib side. Basic window. Screen management. Yep, that's it. The other thing is that here the enum is nice names rather than capitalized. Same thing. Also, all those variables were here. Oh, look at that. We can defer the close window so that we don't have to remember to have it later. Oh, I am switching that immediately. So init window, defer, close window. This way we don't need to remember to have it here, all right? Bam. Doesn't mean we can do the same thing with end drawing. I guess because it suggests that we... No. This is here. That's the end, and the initialization is like after the loop. I wonder, can we just grab this and just put defer end drawing? Is that costly? It shouldn't be costly, right? What's gonna happen if I'm gonna run it now? Just here, I can click. It draws, right? It isn't stuck on something. Huh. I like that. That means that we could take this and actually do something like this. Template. Init drawing. Okay. Well, don't pass anything to it. It'll be just this. Okay. So our code, I know it's pointless because we call it once. But we could just do this, right? Init drawing. Run. And of course, it already switched to another screen by the time I press. Okay, this works. Oh, that's so cool. Hey, instantly we have all the niceties of NIM. So let's keep looking at their code. What other little tricks will we find? This is all regular. Current screen is logo, yes. That was a NIM template, actually. Not even a macro. So the whole idea about the template is that when you call it, the call will be replaced by this, okay? It will be just replaced by this. But you can make something like... We could actually change it. Call it, or like make another one. Template, do draw, okay? I know it's a stupid name, but we could do this. Maybe clear the background because we always do that. And we call end drawing at the end. But here we could do user code or whatever, drawing code. And I believe we could define it as something. It's not exactly text replacement because this, whatever's inside here, is still gets type checked and all the other stuff. Code, and we just specify this is untyped, so I could just do code. So what's gonna happen here is that whatever you pass here will be actually injected here. And the nice thing about it is that, you know, we have this thing, so we can straight up do, instead of any drawing, we're gonna do draw. We don't need this anymore. And I use the colon so I can basically indent this whole thing so that it's inside of that. and it's gonna be called there. And you know what's even more fun? Inside of our template, we can say that, hey, we have let current frame number is 1 to 3, okay? And therefore here in our code, we can just do, you know, what title screen number plus current frame number, okay? Because this variable actually already exists in here in the context of this code inside here. On a string, on a C string, I guess. I guess it doesn't like that we're mixing string with C string. Dot C string. It doesn't like something here. Come on. Yeah. Doesn't like something. Sorry about that. But basically the idea is that I should have this current variable available. I could put some extra functions here available. Or even if I will be returning something from code, this whole thing will be type checked to make sure that it actually makes sense during compilation. So it's not just text replacement, it's way smarter. So I'm just gonna undo a bunch of stuff, all right? And we just do this. Because this template is good enough when it's drawing, and sure, let's put a nice color around it so it looks nicely. And that's that. Alrighty, so we have our frames counter, that's all good. Well, the windows should close. And we do just the case of this. Increase, the same thing, exactly the same thing. Is key pressed enter or is gesture detector tab? Copy paste bunch of stuff. Good. Always the same. Okay, so we came up with exactly the same code. Draw this, draw that, draw yet this, and there we go. Yeah. Just like that. And I would actually like to, because look at all those numbers, they're kind of repeating themselves. Other than here, one number being different. So another little, I just want to try something. What if we would replace this whole thing with another template? So let's just grab one of those. Okay. And let's do template draw screen. Okay. And what we would like to do here is just basically be able to specify the color, and that will be, what is it called here? Color? Okay, sure. I guess we import that from Raylib. So we just place it here. That will be BG color, okay, for background color. And then we have the text color. Okay. And one more thing, which will be the title. Oh, this is gonna turn ugly. Wanted. That's a C string. And then we have the last one, which is the message. And that'll be our message. Sure, that sounds good. So in theory, this could be done just as a method, right? I mean, as a proc. Yeah, this could be just a proc. So not even need to play with any templates or anything. Just proc. This way we can reuse code rather than do something else. And this isn't happy because, oh, so look at that. Now this proc, it wants screen width, it wants screen height. It complains that at this context, it has no idea what it is. If I had those moved in front of it, then it's happy, right? But if I'll put them back, but if I'll make this into a template, it doesn't complain about those. And why? Because when we call draw screen, something like this, just, you know, green, dark green, and well, all that stuff, this call is gonna get replaced by all this code. And at that time, screen width and screen height are already defined. So by the time it's actually compiling the code, it's gonna be fine. So that's the interesting difference. I need to remember about that little quirk because that might be actually really handy depending on what the situation is. Yeah. But if we're gonna make it just a proc, we can just leverage those variables to be global, and therefore we just plop them here and call it a day, right? So that's that, and we should be still able to just call it, no problem. Huh. And the same thing will be here, draw screen, purple, maroon, and all those. And then we're gonna have the last one. I assume it's all correct. And logo can just stay like this, or we're just gonna do draw screen. The background we're gonna make into Ray white. So in theory, we have a background that's already clear to Ray white, and then we're gonna draw a rectangle over it. Oh, why not? There we go. So I just want to make sure that it actually runs. There's no weird shenanigans going on in the background. Okay. Yeah, we're here. Works. Cool. So it turns out we recreated the example exactly the way it was suggested. So, and we know how to draw text. We know how to draw rectangles. We know how to, you know, like, okay, we can manage things in that state. Therefore, we can do drawing. We can defer stop drawing, and we can defer the closing of the window. So that's cool. Wow, I believe we could actually make our own loop as a little interesting template thingy. Yeah. So what if we have something called template game loop? Okay. So for that, we would need to basically have this init window and close window. Okay. So we could basically do it like this. And it's gonna take screen width and screen height. It kind of expects those to be defined. And let's do window name, okay? It's just gonna expect those, and it's gonna defer the closing. Then we're gonna make the frame counter, or we're gonna actually make something like current frame is, or like, no, we don't need to worry about it here, right? Yeah, let's do this. Let's just straight up make it that it defines the procedure, right? Instead of which it calls defer. Then it's gonna set the target FPS to be something. So we're gonna have screen width, screen height, window name, and target frame rate. That's the stuff that we need. But before that, here we have some extra stuff that we would like to set up. So, wouldn't be that pretty though. Because I'm trying to think, what if we can define several sections in some nice way, but then we would actually need a macro. So let's do it that way. We have template. I will call it, we have game loop, maybe game setup. Okay, and this will be where we init the window. And then allow for things to be set, which will be setup code, which is untyped. Okay, and template. There we go. Setup code, and after that, we're gonna set the target FPS, right? So this is basically set up the window and whatever, game setup. Then we're gonna have not game loop, it will be basically game. Let's call it game, okay? That will be main, but instead of providing the init window, we're just gonna do... No, what the hell am I trying to do? Yeah, I'm kind of trying to push templates where they shouldn't be pushed. I see. Okay. Because the thing with templates is that to define something as the code block, it needs to be last argument. So that's where I'm kind of missing the point. So what, in theory, what we could do here is instead of having this initialization, we could just have game setup and put our code like this in here. Okay, so this is where we call the main thing. And then we could just set up the game loop that has the thing in there. But if we would do that, then we wouldn't be able to put the drawing separately because we have update and then we have the draw. So we can just call it update. And that won't do anything for us. Oh, I'm just trying to push it too much. Because I can imagine a little macro that could help us actually do a lot of stuff without thinking about it. Yeah. Let's just have it the way it is right now. Skip no, game setup will be fine. We just need the window name to be defined. Which we can make a constant. Window name. Sure. And look at that. Actually, it knows that this exists at all the context that the template is being used. So there's no squiggly line. Huh. Cool. Target fragment is there too. Okay. So we can just have this and that and that. Right. So let's move on because I'm trying to push it too hard instead of learning the Raylib. We'll get to our probably how we want to use things over time as we go. So we've got camera. Is there something else that's 1 star? 3D camera free, really. I don't want to go 3D yet. No 3D. No gamepad right now. Input mouse. I guess we could learn more about, yeah, let's learn about input keys and input mouse. Or maybe you already know. Move the ball with arrow keys. Okay. I already know how to implement that, to be honest. But let's see if they give us any interesting hints. So, yeah, we do the standard stuff, set up everything. We use vector 2 for ball position. Okay. And these are floats, screen width 2, so we basically make it in the center of the screen. Okay, I would like to learn vectors here, because they'll be really useful. And then basically, if the key is down for each, we just move it a little bit. Okay. And then as we draw, just draw text and the circle. Draw circle V. What is V? As in vector? Possibly. And that's that. Okay, that's gonna be simple. So let's just copy this part. The rest doesn't matter in our case. And let's plop it here. So all that is done, all that's done. Ball position. So we don't play with screens anymore. That means we can get rid of a lot of this stuff. Like game screen, go away. Target frame rate, I'm gonna leave all that be because I kind of like it. We don't need the draw screen and all this stuff. Game setup. Current screen, no. Frame counter, no. We want things like var, ball position. Do we have something like vector? There we go, vector 2. And what's vector 2? Can I control? Yes, I can control click. Awesome. I love being able to look into definitions. So, okay, vector 2. It just has X and Y component, and it's an object. Okay, sure. Floats 32. So if it's an object, we can just do X is, and we were doing screen width, okay, by 2. So we do screen width by 2 and screen height by 2. And it probably doesn't want to convert it to anything. So float 32 dot float 32. 0.0. Come on, work with me. So expected type I got, but there we go. Now it's fine. We'll be fine without the float 32 in there. Should be, because the moment we divide this way, we already convert everything to float 32, as far as I know. Because the division, basically, here you see the operator division. Because it's just a normal name definition, nothing crazy. Take two integers and pump out float. There you go. Sure, if that's the case. Window should close, all that stuff. We have the loop. And a drawing. Clear background. Sure. And current screen. None of that. Sure. So what we should do here is actually, so not in drawing, an update. We want to if is key down. So another thing, pressed will be, I guess, for one split second when we actually press the key. For one frame, it will be active. While does it have description or something? Probably not. No, it doesn't have the actual description. But is key pressed will be just for one frame, I assume. Press repeat will be probably with some interval, just as you would expect when you, I don't know, when you're typing text, you press the A key or whatever, it will just do A, but not as fast as every frame or something. And key down would mean that the whole time that it's pressed down is actually gonna work. So let's do right. Okay, we have right. Then we do basically all position dot x increase by 2. Okay, 0.0. Maybe. Yeah, that works. Left will be subtract, up will be y. Yep, exactly that. Okay, that should work. I hope. And then when drawing, we'll clear the background. Sure, draw text. Move the ball with arrow keys. Okay, location doesn't matter. This is simple. and then draw circle. And I don't think we need to do anything else like V or something, because we already have two definitions. Center for, you know, X and Y, or vector. So we're just gonna use our vector, ball position. Then we've got the radius, sure, 50, and color will be maroon. Save it, and that should be it. Yeah, although you know what, I really want to kind of abstract it away because I like this whole game setup and thing. So let's do it real simple. Template, game, and all the game will be whatever, game loop code untype. So all we're doing here is the proc main, and we just do the game loop code. And after that, we just do main. There we go. So this will be our template here. This means that instead of doing this whole thing, we can just do game. And we can get rid of this. Okay. We have game set up. Then we're gonna do game loop. Template game loop. And will be loop code. And all the loop is just a while loop. Then it executes our code, loop code, and that's all it is. So instead of having this whole thing, we just do game loop. Okay. No extra stuff here. No extra definitions here. And then we're just gonna have our update, where we just do this. And in the future, we could do, you know, like update could have additional stuff. So let's define update. Update has update code, just calls it. And then in a drawing, let's just do a draw. And it'll be draw code. And in our case, we don't need to play with a defer. We just do draw code. So this way we can have it already categorized and labeled with stuff. Draw is here. Bam. And sure, at the end, template deinitialize, which will be just the init code, and we just call it there, and that's it. Bam, bam. Initialize, and we just do this chord. Nothing here. Okay, that looks a little bit better for me, at least. This shows us as not being used while it is being used in our game setup. Code. Okay. Now it's happy. All right, I like this more. Looks less C++y. Cool. So, can I run it now? Looks like I can, and I can move it. Perfect. Great. Can I add some momentum to it? Because we have position. What if I'm gonna add ball velocity? Okay, it's 0. So what we're gonna, and let's do drag, and that will be Sure. This way we could do that when the key is down, instead of increasing the X, we can just do the position, we do velocity. Okay. And therefore, it still needs to be an update, right? Ball position plus equals ball velocity times 1 minus ball drag. That's what I would do. But we don't have operators like that. Will that change anything? Absolutely not. So basically, there's no operator that takes vector 2 and a float and multiplies it, right? Okay. Well, that's not a problem. That's where we can just make our own. So let's actually do it before those. Proc. Times, and we just do vector, which is vector 2, and scalar, which is full 32. And sure, we can suggest aligning it, and that should be it. Why isn't it happy? I'm not sure why it's not happy right now. What am I missing? I don't think I'm missing anything. And plus equals for this doesn't exist either. Interesting. I would expect that it exists for those. Do we have something else like Ray Math? Let me just look up if we actually have anything like that, because I'm surprised that one wouldn't have anything of that sort. These are just examples and a specific example. Naylib. Raymath, mathematical functions for game development. Okay, so look at that. So we have actual documentation. Perfect. So we have things like audio, camera, and there won't be any math. No math here. How about the vectors? Because we have vector 2. Now, types, constants, and procedures for copy, destroy. Lots of access. Wow. An assignment for access. Blah, 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 blah. And that's it. We don't have any addition defined, nothing of that sort. Okay. So we could probably go to Raymath. And what do we have? Add. These are what? Procedures. And look at that. Then we have templates for either vector 2 or vector 3 and vector 4. Multiplication. So let's just import the Raymath and see if that's going to fix our problems. I'm going to comment this out and it will be Raymath. Save. This works now. Okay. I am happy with that. Doesn't mean that I can... did I have something else defined? I don't think so. Okay, sure. So this should work, and that will be the ball position. And over time, it should... because we increase it. Velocity should be calculated differently. So ball velocity, we just multiply it by here. And this way. Because we want the velocity over time to reduce as well. So let's see if that's gonna make any difference. It started. Whoa. To the right. See? One press. Boom, boom, boom. And suddenly we have something, whoa, more fun to play with. Because it actually has, you know, some kind of weight to it. Just like that. All right. So now what? Gosh, this is actually fun to control. Woo! Yeah. Gosh, instantly one would want to add, you know, display which buttons are being pressed, or what else? Or like the vector arrows for debugging. This is fun. Cool. So we created the ball position, right? So that was the keys. Let's see if this has equivalent in nim examples. Blah 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 blah. Input, gestures, mouse zoom. Yeah, this one doesn't seem to have an equivalent. So let's look at the mouse. What can we do with the mouse? Because there's input mouse. Move ball with mouse and click, and move button to mouse button to change color. Okay, maybe we're gonna add this feature to the thing, right? With the mouse buttons, we can change the color. And maybe this will be target position, so the ball kind of chases the mouse rather than just straight up sticking to it. Sure. Okay. This just reminds me to things that I was playing as a kid. When I figured out how to draw simple shapes in Delphi canvas thing and started calculating positions. So that actually wasn't a game framework. Okay, so let's copy this code and look through it in Visual Studio Code. So what do we have here? Standard stuff. So we have, again, vector, the ball position and the color. Okay. And basic and update. Oh, position. Get mouse position. So that will get the position on screen. Interesting. All right. Okay, so the first thing I would like to do is let's actually name it differently. Let's do, because this is only existing in update. Sure. So in update, we're gonna specify that we have let's do it an core position. And that will be get mouse position. Okay, and get mouse position just returns us a vector 2. Cool. So now that we have this, then we have is if left click, middle click is pressed. Button left, button middle, button right. Button side, button extra, button forward, button back. Woo! That is a lot of them. And this is if else, so it just gives up the moment it finds another one. So I still want kind of those arrow buttons to work, right? Or no, maybe let's just ignore that. We'll ignore the buttons. We won't be changing the velocity ourselves. Yeah, I have plans now. So let's do the colors. We can just paste in this code and we're gonna make it every time we see this. We're just gonna make it into is mouse button pressed. And this will be if. And all the else if will be elif. Okay. Yeah, I don't think how to replace those. Left as mouse button. Oh, just like that. Middle. And let's just do right because let's say that there are no other buttons, okay? Bum bum bum. Ah, that's what we need to do. We just need to make it like this. So ball color. That will be in game setup, right? Yeah. In game setup, we're gonna add ball color, which will be the maroon first. Okay, that's good. So we've got this and then LF and val indentation. Really? Do I really need to do it this way now? Or am I missing something? Oh, now it's good. Okay, sure. So this is basically our colors. And we should already have this anchor position. So I'm gonna do something simple first. Let's get rid of the text. Let's do draw circle. And this will be the anchor position. And we're just gonna make it smaller. And we're just gonna make it some color like... what colors are there? Color dot... Come on, where are the colors? Really? Maroon? I don't know the colors. And this would be the ball color. Just so we can try to start this. We should have two balls on the screen. And I actually want the anchor to be over the ball. So we always see it, okay? The anchor point. And this will be the ball. So let's run that and see what happens. Okay, there we go. I'm moving the mouse. I'm moving the one circle. Well, the other stays. But when I change, click mouse buttons, the other circle changes colors. Cool. Let's make it... Is there black? There we go. We got black circle. Awesome. So what I would like to do now is make the whole thing, the big circle, act as if it's attached by a rope or something. Maybe not a rope, by some kind of string. And that could be fun, right? So first we're gonna make it work as it's like, nearly 0G or something. So on update, we have the anchor position updated every time. So the next thing we would want to do is basically, let's also make it something like spring length. Okay. And let's do it 100. I don't know how springs work, so I'm just gonna continue with that. So let's see if we can get some kind of vector math. Let distance to ball get distance? No. Let's check our... We had the ray math, right? Is there something like distance? No, nothing of distance. Length? Pressing enter, but I'm not seeing anything. So let me just length. Oh, there is length. So the search doesn't work. That's all. Compute the length of quaternion of a vector. Oh, there we go. So we can subtract one from the other one and get the length. Okay. So we do anchor position minus ball thing. And we're just gonna do the length. Okay. That should be it. We get float 32. This is the ball. So basically, if this is the ball is So we have two options to decide on here. Either that we have, like our anchor point and the ball, and the spring in between is always pulling, but the closer the balls are, the less it pulls. Or we make it that it pulls only if it's beyond some length. I think the beyond some length might be more fun. Okay. So let's do that. If distance to ball is larger than spring length, then we're gonna calculate the force, okay? The force is sure, the how much we overstepped divided by spring length. So this will be the difference. So yeah, this is larger, this is smaller, and divided by that. So if it's gonna stretch twice, it's gonna be different and whatnot. Sure, we can start with that. Multiplier, okay, and then we'll do so what we should do now is let force is the force multiplier times, let's just call it force, sure, times, let's do spring strength, okay, spring strength, and that will be 10 or something. Sure. So now we can actually change the ball velocity to take the anchor position minus ball position. So now we're starting to enter the realm of what's where and in what direction to pull, because if we get the anchor position minus the ball position, we're gonna get the vector from this one to this one, right? That's that, but now we would need to normalize this vector to then multiply it. Do we have normalized line angle? Calculate angle defined? No. Normalized. Normalized provided quaternion or vector. Perfect. Just normalize. Okay, awesome. Normalized times the force. Okay. What's the problem now? Spring length, 0.0. 0.0. Save. Okay, this is just giving me stupid answer. Spring, not sprint length. Okay. Sure. There we go. Yeah. Yep. Let's see what the hell's gonna happen now. Because we already updated the ball position depending on the velocity. This is probably gonna just explode. Knowing how... Yep. There we go. Goes around. This we definitely need to increase the drag. So let's do the drag to be 0.05 or something. That should make a big difference. Or not really. I mean, kind of, right? Oh, look how the thing is kind of moving in. Instead of just orbiting, it approaches like triangles or something. It doesn't move exactly like a planet or something, because it starts changing the direction only when it reaches that little area. So do we have the... Where do we define the spring length? Let's do this. Let's also draw the spring length, okay? So we have our anchor point. But before we draw anything, let's draw circle. It'll be at anchor position. The radius should be the spring length, I think. So we have draw circle. Can I make it like not really fill or something? What is the problem here? Not crawl circle. I'm making lots of typos. Sorry about that. Yeah, nothing else. Radius. So what I'm gonna do is draw another circle, which will be that spring length minus like 2, and that will be the background color, which will be ray white. And this should draw a kind of circle with an outline. And over that, we're gonna draw everything else. There we go. So you can see that it just stops here, doesn't move. When I drag it out of here, I can kind of pull it. Huh. That's kind of cool. So now we can play with it a little bit more. First of all, I would like to increase the radius, the spring length to, let's do 150. And what's going to happen if I'm going to increase the spring strength from like 10 to 50? I think it's going to go nuts. Yeah, kind of. So we've got it here. Bam. Look how quickly it just goes nuts. Yeah. So I've got a better idea, I think. Huh. It's cool. What if we're gonna keep the spring strength at like 5 only? So nothing strong. What we're gonna do is make the force to be square root. Okay, so we could probably just do it. Sure, force is just squared here. And that means that the further it goes out, the stronger it's gonna start getting, I think. I mean, I could define it probably somewhere else with the spring length rather than force. And then apply this. Yeah, let's do it this way. The strength will be applied afterwards. Although it's not like it matters, right? This divided by that, that's the distance. Sure, whatever. Let's just see what happens. Whoa, now it's extra slow. Okay, I didn't expect that. Oh, I know. Huh. It's all because of this. Because this calculates how far away, like how much further than the string length it is. If this, and then defines it by that. So the value, if a little bit out of thingy, it will be just increasing very little. Oh, I don't know how to describe it quickly. This needs to be 50 suddenly. Oh, come on. What's going on? Oh, something didn't close because I can't use the terminal. I can type here, but I can't type in the terminal. Oh, it's stopped now. And it trouble stopping. Interesting. Yeah, because the values are so small, it suddenly becomes very... They're not eager to move. To be honest, I didn't expect that turn here. Divided by spring length by 10. Sure. Still kind of sucks. Doesn't have that nice springiness. So I think we're just gonna ignore all this squared whatnot. Let's just make it the way it's supposed to be initially. With a strength of just 5, the way it was, and see if that just is still fun. Right now it's not. Blah, 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 blah. What's going on? Why does it get so sluggish? Let's look at that. It's so slow. Am I missing something? I'm not sure if I'm actually missing something. Suddenly it slowed down like crazy. Unless I just make it extra strong now. But I don't understand. I guess that distance changed so much. Not really. Look at that. It's still sluggish. That doesn't make sense. It's like as if it didn't recompile. So let's do this. Will it change if I change the length of the spring suddenly? Okay, it recompiled. The string size changed. It's as if we had limited max speed. What the heck? We increase it. So, distance to ball, force, that's fine. And then force times spring strength, which is times 30. And then we do... Oh, we don't... Oh my goodness, what the hell am I doing here? Let's get things back to where it's supposed to be. Alright? We've got this with the thing, but we just need to multiply it times force. Duh. Now we're missing the ball. What the heck just happened? 5. This is good. Sure. There we go. It's kind of... See how sluggish it is when we're just touching the border? But then when we go, it just goes whoop, nuts. Wonder if that was a good idea. To increase it that much. Yeah. We're gonna do this and see if that's a little bit more manageable without this quadratic whatever. Sure, that's manageable, okay? That's 100% manageable. So now the only 2 things are left. I want to draw a line between those 2 so that it looks like they're actually attached and add simple gravity. And this way things will, forces should start canceling each other out. So how do I draw lines? So what does normalize method do? It basically takes the vector and makes sure it kind of scales it down by number so that the largest, either x or y, is either 1 or -1. So if you would have, for example, x is 14 and y, x is 15, while y is -3, right? After normalization, x would be 1 because that was the largest one, while y would be, oh gosh. That's a bad example. Let's do 4 and -2, right? So x will become 1 because that was the larger one, and this will be -1, -0.5. So this way, normalize just makes sure that the vector is basically representing a direction with constant length. The length of the vector always stays 1 and the direction stays the same. Oh, that's a better description. It just scales the vector. And just in case you have x is 0 and y is 0, it will stay the same because you can't extend 0 to in any direction. So very handy. In our case, we're basically taking the direction from ball position to the anchor, and we're turning it into that vector of length 1. This way we can apply a precise force to it. So no matter if they're far away or not, this will always be the same thing. So yeah, it's a very fun, very useful thing. So we just got that with other things. So how do I draw a line? Let's see if I'll start typing in draw a line or something. Draw text, texture, triangle. Oh, there's draw line. Okay. What do we have in here? Start position, end position, and color. Okay. Perfect. And thickness. So it'll be from anchor position to ball position. We're just gonna make it black again, but let's make it 3.0 for thickness. Let's see if that's gonna work. There we go. We've got our line. Oh, that's awesome. Cool. So the only thing left is to add gravity. Woo, woo, woo. So let's do gravity, gravity, gravity. So in our game setup, we'll just gonna do var gravity vector. Or just gravity, okay? And that will be vector 2. Y is... Wait. Up in Raylib, I assume will be negative. Down will be plus. So let's just do 1 for now, okay? And what we can do is basically, when we create a, ball velocity, we always just add the gravity. And the not nice thing here is that we should actually divide it by, wait, what's the problem now? Oh, var, me misspelling things. Let's just divide it by target frame rate, kind of. Let's just see what happens. Run. It's moving ever so slowly. And why? Because our drag is strong while our force is really small for the gravity. Because we're dividing it by the frame rate while nothing else is affected by frame rate. So let's just skip the frame rate. We're not playing with that yet. We haven't figured out how to get delta time yet. Oh, look at that. It's kind of here. I'm gonna let it go here. It's just gonna bounce off and slowly slide down. Okay. That's good. So let's make the force a little more fun. 5 or something. Yeah, this is starting to look like something interesting. But that force definitely needs to be more. Let's do it 25. Something that's gonna try to stretch it over the limit. Come on. There we go. Get frame time returns delta time, right? Sure. I'm sure there'll be a tutorial that will tell us about it. Hey, this is fun. I don't know, this is so small and stupid, but it's so buttery smooth, but that I just want to play with it. It's so silly. Yeah. So, you can see how bouncy it is, and that's only because we have this whole springiness to it. Boink, boink, boink. So... yeah, the other thing interesting here would be to add mass, and mass would probably change how the drag works on the thing. So, you know, larger the mass, the smaller the drag, or some other aspects of physics, and that could probably make it something fun. I just really want to crank up the gravity to like 60, and maybe the drag to be 0.8, like extra large or something. So look at that. Now it kind of behaves more like you would expect it. You need to really work it to swing around. Huh. And then what? Add physics to the... gosh, now I want to make the ball bounce off the screen. Yeah. Because the anchor can't get off the screen. So, gosh, this is fun. I forgot how much fun it is to work on those really simple, basic coding things. And yeah, I know the code is ugly, but whatever. Var bounciness will be 0.5, so it's gonna lose some energy. Yeah, exactly. Who needs physics library? You can just play with your own. Okay, we've got a bounciness. So now we would just basically need to do checks for the thing. So ball's radius, and right now we have it set to just display as 50. So let's do ball radius here, and this will allow us to do checks. And yeah, so we've got update, all those things, distance to ball, blah blah blah, the forces and whatnot. That's basically the thing. But then at the end, after we kind of place the ball somewhere, we would need to check if it crossed over the edge. And if that would be the case, then we would need to move it to the edge and reverse the vector, like the velocity vector or something. There are so many ways to approach it, actually. But let's keep it as simple as possible. So we just calculated the ball position. Let's actually add comments. Calculate force, or the pull force of the spring. Okay. Sure. And update ball velocity. Random color changes. Let's get rid of that. I don't like that feature. It's pointless. Then will be calculate ball position. I mean, this is ball velocity too. It's just like kind of weird. Calculate ball position. And then now we'll have bounce of walls. So let's do if ball position X is less than ball radius. What is it even suggesting? If ball position X minus the ball radius is less than 0, right? So if it's on the left side of the wall, then we're gonna do that the ball position X should be basically the ball radius, right? Because a little bit offset. And then velocity on the X side will be basically bounced off. Sure. Let's just do that one check for that one wall and see if that yields any results. Come on, drag it. Oh, this is so satisfying. And it just stays here because it can't do anything. Bam, 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 bam. But it doesn't feel too bouncy, right? Because I'm tempted to do one thing. Because the moment we kind of slam it here, maybe we should leave it. Yeah, let's leave it this way. Sure. This is kind of effect that, because the thing is that when we slam it, the ball really wanted to be somewhere way inside the wall. We teleported it back to the wall, but really in normal situation, if it would bounce off, it would want to kind of already be a little bit off the wall during that frame. But let's say that this is due to the ball being squishy. The squishing takes time, slows things down. So just hugging it to the wall will be fine. Because if we would make it offset suddenly in a situation like this, it might want to vibrate a little bit or something, which will be unrealistic. So this is good. Oh, this is so good. Else, if the position X plus radius is larger than screen width, yeah, then we're just gonna do this thing. And then for the Y, and I think that'll be it, right? Let's try to run it. Gosh, those simple things are so simple. Oh, what the hell just happened? It got glued. Come on, get off. That wasn't intended. So we've got something being set the wrong way there. So for Y, minus the ball radius, so that's up. We do Y is ball radius and negative the bounciness. Well, else if ball position Y plus ball radius, larger than screen height. This is correct, but something tells me this is tricky. This is tricky because basically every frame we're reversing the ball velocity, okay? And therefore we can't pull it because the moment we're pulling it up, at the end, even though it was kind of touching already the whole thing, it, I guess didn't have enough strength to be pulled up, it just gets reversed. Yeah, so that's bad. I guess this should happen. Ay. Huh. we move it for minus 0.1. Will that fix the error? The problem? Nope. It just gets stuck. Still gets stuck. Instantly gets stuck when it goes down. And there's no force that we can use to pull it up. I guess that's why somebody uses the physics library, right? To not deal with bugs like that. Let's temporarily not make it move, okay? And let's see if that changes anything. I mean, let's not reverse the y velocity. See, it just, bam, stops. But I can lift it up. The top doesn't have any problem because the gravity helps us to remove it or whatever. So with the velocity, we can still reverse it, but let's make it that we reverse it only if it's pointing down. So if ball velocity is larger than 0, then we're gonna reverse it. Otherwise, we won't, because there's no point then. And that should make it possible to unstick the ball from the bottom. Yes. Well, it doesn't bounce anymore. While walls and everything else bounces off. So velocity y is down. And only if that velocity is larger than 0, we reverse it. Otherwise, we don't touch it. Okay, this is weird. Come on, slam it in there. Yeah, this behaves strange. Especially here where gravity helps it. It just bounces off forever. That shouldn't be the case. And here we have the reverse. What the heck? Because if we're gonna do that, it's probably just gonna stick itself again. Yep, it just sticks. Weird. Times 2. And here divided by 2. And we could also do f is less than this. Then we're gonna switch it, right? Otherwise not. Huh. Okay, that kind of bounces less strongly. But we still... Oh, we got to bounce off a little bit. Look at that. So there's just... Oh, I know, because our gravity is probably so strong. Because look how far away it's pulling it off the thing here. So basically when we slam it down, the gravity instantly just runs everything. You know, we can just increase that the bounce will be even more. And that should make it kind of work, right? And oh, we've got a problem. Thing froze again. It's gonna need a moment to... Interesting. So the app from time to time, when I just close it, it kind of keeps running because I can't type anything. Freezes the... Oh, look at that. Huh. Very interesting. Wonder if that's some kind of bug or... I don't know. Okay, we've got... But it's still so sticky down there. While walls are nice and bouncy. But yeah, this is fun. I didn't expect as much fun with Raylib, to be honest. But yeah, the fun... Now I just want to make flawless simulations. Like the brute force ways. But no. So we've got the colors changing with the buttons pressed, right? So that was not very exciting, but we learned how to grab the mouse. Let's see if we have anything else. What's this? Input mouse wheel. We could do that. This way we could increase or reduce the strength of the spring, I guess. Use mouse wheel to move the cube up and down. There we go. So how do we do that? All that is fine. Scroll speed, we just set it up here. Scrolling speed in pixels. Get mouse wheel move. Times scroll speed. That's it. Okay. So we could use that. Get mouse wheel move. So in our update for the spring strength, let's make it before anything happens. Process input. Okay. If what was it? Get mouse wheel move. So this is wait. Mouse wheel move. One is just move, and the other one is vector. I guess it tells us which vector. If somebody would have mouse with left and right, I guess scroll. Okay, so sure, var or let get mouse. No, we'll just do straight up. Spring strength is get mouse will move times 0.5. And we could probably also, what's the problem? Strings. I have typos everywhere. Look at that. Strength. English is hard. Okay, so this should move it. Let's just also print it because I would like to know what the strength is. So on top of everything, draw text, and we're just gonna make it spring strength, right? We add the spring strength, and it just doesn't like that we're trying to add. So left and right is strength, but oh, I forgot. We just need to use ampersand. That's what we're doing in nim. And now it's unhappy because implicit conversion to C string. Dot C string. That's not explicit enough. We wrap this whole thing, maybe. No. What is the problem? They're both this. It should run anyway, right? Yes. Spring strength shows 0. Wow, okay. Because we assigned it. Let's increase it. Okay, we've got 5. And look at that, we can increase it. And this just pulls the thing up. We increase it to 100. Whoa, now it just goes crazy. Or we decrease it to something like 1. Or 0, and then negative. Oh, look at that. We can just do negative. Now it's gonna try to run away. Okay. Oh, but it's hard to overcome the upward force, huh? Yeah. So that's fun. So that's the scroll wheel. Sure. Wow, these are really small lessons. Input multi-touch, we're not doing that. Loading thread, that's interesting. Random values, how they suggest doing that? Get a random value, okay? I guess we could use nim for that and just ignore that part. Scissor test. Move the mouse around to reveal this text. To toggle scissor test, S. Huh? What is that supposed to be? Scissor mode is true. Area. Begin drawing. Begin scissor mode. What? Clear background. If scissors mode. Begin scissor mode. In that area. Okay. Draw rectangle. Draw full screen rectangle and some text. Only part defined by scissor area will be rendered. Oh, okay. I see. And then end scissor mode. Oh, so we can just make a little area that we are actually drawing on. And then the rest is not being drawn there. Huh. Really? That is actually really cool. Oh, that would simplify a lot of things. So basically what the scissor mode would be is basically we define the area. The library will basically make a buffer that, you know, all the further drawing instructions will be just drawing into the buffer, and then after we end, it takes that computer buffer and just pastes it there. Okay, that's cool. Can we grab that buffer and just get it from the GPU and put it in multiple places? That would be even better. But I guess not. Okay, good to know it's there. That's really simple. Any other 1-star lessons? Window should close. Are you sure you want to exit program? Yeah, basically close window. Okay, so these are all 1-star lesson other than 3D camera and stuff. I don't care about that now. So let's go to 2-star lessons. 2D camera. Sure. Let's see what that is. So when we're here, mouse wheel will basically zoom in. I wonder if this will be with matrices and stuff. AS to rotate. Okay. And right left to move. I'm sure that's gonna be with matrices. So what do we have here? Define max buildings 100. Huh. I'm glad in NIM we don't have to define constants that way. Okay. Create a window, rectangle player, sure. Buildings, how many to fit in there? And building colors, whatever, to just draw the buildings. So we have the spacing of 0. Just change that song. This shouldn't be in this playlist. Alrighty. So what? This is just drawing the buildings. No, this is just creating buildings. This is initialization. Okay. Yeah, and then we have camera 2D. Okay, create the camera. What the target is? Okay, so the location of the target. The offset. Rotation and zoom. Okay. So player movement, all the stuff. We just update the player location and camera target follows player. Camera.target is we just always update it to be on top of the player. Just a little bit offset. Okay. Sure. Oh no, these are because the player is 40 by 40. Yeah, that's why. If you have those dimensions, why do you hard code them here? Come on. Or just get a whatever. Camera rotation controls. Limit camera rotation to 80 degrees, so plus minus 40, sure. Zoom controls, sure. We all know that already. Where'd it go? So if R is pressed, we just reset it. Sure. And drawing. So now the interesting part. How the hell do we draw it? Begin mode 2D camera. Oh. I know what's going on here. We draw the rectangle and all this stuff here for all the buildings. The player rec. Oh, rectangle from a rec, as in, I guess there's a type rectangle. Huh. Okay. I see. So we draw things as they normally are. The player where it is, the buildings where they are, all the lines and whatnot. All that stays the same. And then we exit the camera mode. And then whatever we're gonna draw is gonna be basically in a normal space. So what this camera does basically is that I guess applies some matrix translation, I guess, as in rigs the coordinate system from on screen to kind of in game. And that's it. And that means that we can basically pretend that we have a larger world that exists in here instead of worrying about the screen itself. Okay. I can live with that. If it's built into this whole thing like that, sure. It's just how hard is it to make your own? Because that would make it even nicer. So I mean, now our ball example sucks because it's kind of hard to add a camera here. But why not? We're gonna add a camera to it. Why not? So let's just put this on the side. And let's plop that camera there. Alrighty. So I don't care about the rectangles. We already have the game world stuff done. So what we actually want to do is none of that. Create a camera, okay? This is a type, so I guess a nim will be nice and you know. Variable camera, which will be camera 2D. There we go. So camera 2D. Create a new one. Do we have anything to specify what's in there? Camera 2D. Offset, target, rotation, and zoom. How do we create it here? With nothing. Is there like new camera? The camera matrix. Oh, we can get the camera matrix. Look at that. Okay. Update camera. No, we just create camera 2D. And we just set stuff to 0. So we basically... Okay, here's the camera. Now camera target is the... Oh, this is gonna be weird because the moment we move the mouse... Oh, this is gonna break things. The moment we add mouse, everything's gonna go wonky. Yeah. So let's just say that this will be, the camera will be, basic target will be half of, you know, the center of the screen, and that's it, okay? And the offset, what the hell is supposed to be, offset supposed to be? Screen width by 2, let's just make it 0, 0 for now, okay? Because I'm not sure what this offset itself is supposed to be in this case. Because we have target and the offset from the target. This is just like a convenience method or something. I don't want to an offset right now. Camera rotation 0. Camera zoom 1. Okay. So this is our basics for the camera. And then we basically would be updating the target and the other stuff, but I'll leave it for now. It's just we have the begin mode 2D for the camera and end it there. Oh, when you start drawing two things with two different cameras, oh gosh, you could do weird stuff. So in the update, we have the calculation stuff. We don't care about that. We just want to draw, circle, line. Yeah, all that will be begin mode 2D for the camera, okay? Sure. And we just go here. We'll do end mode 2D. Right? I guess you can't begin mode for a camera without another mode for a camera. Or maybe you can, and you just end them one by one, and that's it. Interesting. Sure. So we've got that. Let's see what happens if we're gonna try to run it. Because I really don't know what to expect. Attempt to call routine vector 2. Where? Shows there's a problem here. Oh, we just need to specify it. X and Y. There we go. And whoa, okay, so look at that. I'm moving a mouse. I have it in the bottom right corner. And it's here now. So, and this is the ball is like kind of here. So I guess that's the offset that I'm missing. Yep. So initially the offset needs to be basically the same thing as this. Or negative? Don't know. Let's see what happens. Okay, now we're good. Okay. It all works as it's supposed to. Okay. So what if instead of changing the with the mouse wheel, instead of changing the spring length strength, let's do camera.zoom and we're gonna do it 0.05 or something. That means we should zoom out, but our cursor should still be kind of mapping to the whole screen. And I zoom out. Look at that. I can't. No, what? Yep. There's a wall there. I can't get past it anyway. So we basically did that. So what we could do is add kind of walls, right? We could make... Do we have like draw rectangle or something? I believe. Draw rectangle. Position, width and height. Sure. Position and size. Or... It's just the position X, Y, and size. So position X will be -10. Let's -100 and -100, or like 0 for Y. And then width will be 100 and Y will be screen height. And that will be black. And then we have, so that's left wall. The right wall will be screen width 0 as well, and then we have 100 and screen height. So this will be left wall, right wall, from 0, -100 up, screen width, and this will be good, and this should be bottom. Let's hope it didn't screw it up. So now we should actually have walls displayed. Normally we don't see them, right? But when I start zooming out, there you go. There are the walls. Cool. Simple enough. And I can zoom in. Whoa. Huh. It's interesting how the circles actually have polygons. So Raylib in the background makes this circle out of a mesh. Okay, I can live with that. This way we have always crispy edges. Sure. Cool. Okay, this is fun. So what tutorial were we just following? Oh, the camera. Okay, so we learned that. Then camera to mouse zoom. That's literally it, the zoom that's attached to the mouse, right? We'll move and just set the offset for the mouse is, oh, this is just so that we can zoom in into the area that we're looking at with the mouse right now. Okay. No need to learn that. 3D camera first person. I must say that actually sounds fun now that we're learning that, because yeah, this kind of sounds fun. But how do you draw cubes and stuff? Do you draw rectangles and just rotate them or something? We'll get there. 3D picking. What is it? Oh, that you can just select if it's clicked or not. Okay, cool. Drop files. Drop a files to this window. Okay. Input gestures. Oh, all that swipe down. No, thank you. I'm not into mobile games. Don't remember last time I played a mobile game. Years ago. Storage values. Plus R to generate random numbers. Enter to save. Space to load. What's so interesting about it here? Storage position and score. Okay. So that's our storage data. Save storage value and load storage value. Persistent storage functions. How persistent? What? Do we define them? Save storage value. Success, all this stuff. Oh, geez. This is file IO and stuff. We can do that in NIM way easier than this whole thing. I guess C++ needs some fancy helpers to make it even possible to attempt to do something. If it's executed inside a window, you can resize the window and see the screen scaling. Ooh. Can I scroll or something? Escape. Oh. I saw a scroll for a second. Click outside canvas. Good one. Yep, I can't scroll. Oh, tab allowed me to jump down. Oh, come on, tab. What the heck? I guess it always fills this whole screen. And it just doesn't let you do anything. That's a silly example. We don't need to worry about Windows stuff yet, right? So what was I doing here? To start, we have world screen, which is cube position and screen space coordinates. Okay, so we have some basics on how to relate screen to the stuff. So let's just look at the other thing, which is the 3D camera. 3D camera, the 1 star. So we can look at this. And look at that. WSD to move. Mouse wheel, you can zoom in and out. And pressed to pan. Okay. Very awkward pan, but pan enough. And Z to zoom to 000. Sure. Okay. So how do we do that? We set the camera. Define the camera to look into our 3D world. We have the position vector 3. Okay. Target up. FOV for Y. Interesting. Projection camera perspective. Okay. I guess I can zoom it back in for everyone to be able to read. And a cube position. Okay. Disable cursor. Set target FPS, all that is normal. So main game loop. We do update camera. And we just call camera free. Why do we call that here? It's key pressed Z. Then we just camera target vector 000. Is it supposed to... What the hell? Is the camera target literally the point that you're looking at? That's so weird. And why the... Oh, update camera is probably our function? No. Oh, probably the update camera and everything that's like already included in Raylib just so that we have something. Begin drawing, clear background, begin mode 3D, draw cube wires. Okay, so we can draw cubes and that, and draw grid positions, and that probably needs to be in the mode 3D. And then on top we can do 2D shapes. Okay, that's simple enough, but tell me more about this whole, because that's 3D camera free. 3D camera mode. Welcome to the third dimension. Huh? Same stuff. We just do draw it and we don't do any update camera. Huh. Where was this one setting that it's free? Oh, this is probably the control scheme or something, camera free. Ah. Camera split screen. Picking, which will be set the position and target. Huh. So the target is literally where the camera is looking at. And the position is the current position. So I guess one could specify... Oh yeah, so you can still directly access those. But instead of calling the camera update or something, you can just set them yourself. It just you need to do a little bit of math to figure out how to actually make it work or something. Because you have position, the target. Where's up? I guess camera up vector, rotation towards target. Okay, I guess. Yeah, because if you have one thing and the other, you can look at it and from various rotations. So you need to specify that the up is there, so it's gonna look like that. If up is there. If up is there, it's gonna rotate the camera to look from the side. So this kind of resolves all your weird quaternion math. Cool. I want to play with that. So we can draw cubes and stuff. Sure. Again, printing and stuff, cube wires, and that's all that we can see. Just a bunch of cubes. Do we have anything else? Shapes? Some basic shapes available in Raylib. So we have polygons, triangles. How do you draw a circle? Well, one is gradient, one is normal, one is... I want to see that. I mean, in some way, I would like to just play with simple shapes. Because you can do a lot in games just with shapes. But what? Draw circle gradient, or draw circle lines? Okay, that's simple. We have rectangle, triangle, and polygon. Okay, polygon, and we just... what? Draw poly. It's vector 2. So this is the location where we draw it. 6 as in 6 faces, and 80 as radius. Yeah, that's what it is. Okay. And then draw line for just the random line up there. Okay. Sure. Okay. Bouncing ball, there we go. We made an advanced version of that. Colors. Logo, I guess this is how we can... This is not a texture. Oh, okay. I see. So we just draw the rectangles and draw text. Really? Raylib. What font is that? Oh, it uses that font everywhere. Cool, I like that font. I wanted that font for the thumbnail for the video, but I didn't bother too long looking for what kind of font is that. Animation, so this is kind of animation where we're gonna draw that, increase this, and bam. It's probably a lot of tedious code. Counters, oh dear god, yeah, nope, that gives me a headache. No thank you. Rectangle scaling. Okay, lines Bezier. Look at that. Oh, this is fancy. I always wanted to draw Beziers, but I didn't want to make a math for that. Start point, end point. Where's the draw? Begin drawing, clear background, draw text, draw line, Bezier. And here we have the interpolation. Okay. Okay, this is way simpler than I expected. Collision area. Huh? Is there like detection for collisions or something? Oh, look at that. We've got collision detection. Moving box. Moved. Box collision. Collision rectangle. Top manual list limits. Blah, blah, blah. So an update. Bounce box on X screen limits. Sure. Move the boxes, make sure it does not move out of the area limits. We don't care about those. Now check spot collisions. Check collision rectangles, okay? And that gives us collision. And collision is just true or false, okay? And we just calculate it ourselves. Oh yeah, it just says if there's a collision or not. And when there is collision, just draw a rectangle from where? This divide by 2. Okay, so this is like a fake. We don't get the actual collision area. Following eyes, easing ball animation. Oh yeah. Easing rectangle array. So just some diagrams and splines. Okay. Wow. All right. Thickness. B-spline. Okay. Oh, that's cool that there's just all that in. Okay, this is way more than I expected, to be honest. And whole Bezier thing. Okay. Sure. This is pretty good. Top-down lights. What? How does that work? Show shadow volumes. Okay, this is a little bit more advanced example because... Huh. Okay, this is kind of math that I don't like dealing with. Oh, we can do multiple. How does shadows... Those... Gosh, these are weird shadows. Because they kind of have bands in between them. Huh? Raymath. RLGL. Custom blend modes. I see. Okay. So this is way more than I would normally deal with. So no thank you. I'm not learning that yet. We had textures, text. Okay. So a bunch of things. Models. So this is straight up loading models. Cool. Is that a mosquito? Come on. Mosquitoes just absolutely love me. All right, so yeah, let's just play with that camera 3D, okay? Can we draw anything in cubes? That's the question, but I guess we would just need to get the models, right? Whoa, where did that go? Z. Okay, so what I'm gonna do is I'm just gonna recreate a simple 3D camera mode, okay? We just have this. We can move and nothing else here. So we're gonna start from scratch and just recreate it, okay? So all the bouncy stuff, delete. There we go. Or maybe not delete because we still want to have the rough framework what we're doing with. So we have the screen width and height. the window and whatnot, so we'll leave that part with the game and stuff. Okay, that stays. But now constants stay the same. Program main entry point. Okay, so we've got our game here, and instead of having all those ball positions and whatnot, we'll just do our camera. We camera 3D. Okay. And now what? Position will be sure, vector 3, 10, 10. That's fine with me. Target, looking at the center. Camera up will be Y up. Interesting. How does this need to be updated? And what is X, Y, and Z in here? I would like to learn about this because this is interesting. Then we've got FOV, sure, 45 degrees. And projection, camera perspective, yes, please. And then we have cube position. Sure, 0. That's cool. So what? Then we set our target stuff. That's already done automatically. So game loop, update. So on the update, we're not doing anything. We just begin drawing. So update, let's just do Discord. Okay. Don't have any inputs, nothing. And on draw, we're gonna do clear background. That already happens. Begin mode 3D for the camera. Okay. And then we're gonna do draw cube. Okay. Cube position, size 2. I'm gonna make it red. Draw cube wires. I guess that's something extra around it. Oh, just so we see the edges of the cube, I guess. Ah, okay. So the cube is just one blob of color. Okay. And draw grid. Okay, there's lots of drawing stuff. Drawing methods. We need to investigate more on how much there is. And then draw text. Welcome to the third dimension. Blah, blah, blah. And draw FPS. What? There's even that. Handy. And nothing else. Well, let's try to run it and see if it actually displays. Error. Camera perspective. Oh, yeah. Camera per... Oh, just perspective, right? There we go. There we go. There's our cube. Although... Wait, what? I guess we're not setting the background color. Okay, that makes sense. So on our draw, we'll have the clear background. Sure. Now we've got the proper FPS, and we've got our cube, okay? Very faint edges of different color. So now I wonder, what if I'm gonna move the camera up, down, left, right without changing the target? Because something tells me it's just gonna keep looking at the cube. So let's do that. On update, we're just gonna do if is key pressed right. Okay. Let's do the camera dot position. Let's do that. X increases by sure that much for now. Otherwise, if what the heck if left Then we're gonna decrease it. And then we have up for... What is Y? Up or down, or Z is here? That's a good question, because it's different in every engine for some reason. Sure. So that should be it. We just update the location of the camera. How is it going to affect it? Up. Okay, something tries to change, but I guess I have such minuscule values that it doesn't matter. So let's speed it up 10 times, or maybe even more. What's gonna happen now with arrows? Oh, I have key pressed. That's why. Key down. So now let's actually decrease it, because it's gonna go crazy. Look at that. I'm moving the camera to the left. It just keeps the thing. And down. Okay, so Y is up and down. Gosh, the zoom is very strange here. Because it kind of moves in way more than I would expect. But sure, that works. So what if I'm gonna switch it to WASD? D, A, W, and S. Okay, will that work? Or do I need some special key something something? No, it looks like it just works. Okay, so that's cool. I'm just gonna speed it up a little bit because it's still a bit slow for invisibility. And then what if I'm gonna move the target like left and right and whatnot? Because I have an idea how to make it easy to move up and down and whatnot. So initially, if is key down, and we're just gonna do right. Okay, what we're gonna do is the camera target X is increased. Okay. So that will be just the cube moving. But yeah, the grid will stay the same place, but the cube will be moving. So let's see. I can move the camera, okay, up and down. And now I'm moving the target for the cube, so I'm moving where the camera is looking. All right, now we're talking. And I'm doing double arrow thing. So now let's do it that way. Instead of calculating that, I mean, instead of saying that when the camera is looking, sorry, I'm reading your message so late, CPN. CPN is saying, check out some 3D stuff. Definitely, I'm checking that out. So now let's say that instead of specifying that in a game world, I want the camera to look somewhere there on that thing. What if I would be basically taking a camera location, moving that target in front of the camera, okay, that's the target. And then when I want to move it, I kind of rotate it a little bit, bam. And this way I should be able to move the camera look a little bit more properly. Yeah, so let's try to do that. Although I don't know how to do rotation on vectors, but let's do it that way. So if we press right, we want the var target is camera.position. We have position, and then we have the so let's do camera target minus camera position, and we're going to normalize it. Okay, every time we just normalize it. This way we have vector the points where camera is looking at, from the camera position to the target, wherever that could be. And then we're gonna not increase the x of the target. We just need to rotate it in the specific axis. So let's see if we have any fun math stuff here for vectors. Prox add, do we have, I'll search for rotate. Rotate, axis, vector 3 angle, look at that. Create rotation matrix from, oh, matrix, great. Rotate vector by angle. So that's vector 2D by specific angle. Rotate by axis angle. So we get the vector. Wait, what? Rotate a vector around an axis. What is V here? A vector? Axis, which is another vector, and angle. Sure, we can do that. Rotate by axis angle. Hell yeah. Rotate by axis angle. So we do target dot rotate by axis angle. And the axis here will be, if we're doing left and right, it'll be the y-axis. So vector 3, x is 0, y is 1, and z is 0. And we're gonna rotate it by how many degrees, right? Angle. Just an angle. What is an angle here? Is it a degree or is it a radian or something? We're just gonna start with 0.5 because this is on key down. So we've got that, and therefore camera target. We'll just update the whole target is target. Okay, that's the target. And therefore for the, wait, this is right, left will be what, negative angle? Let's just see what happens with this. Has to be used or discarded. Oh, that creates a new vector, right? Yeah, that creates new vector. So we do the target is this thing. Sure. Let's just see what happens with the left and right now. Nothing. Really? But then we just update the whole target to be something and then rotate the vector. We normalize the vector. Oh, okay. That's right. Target is the camera position plus target. That's the problem, because we had just a direction at that point. Left, whoa, and right. Okay, hey, we're rotating. We can just keep going. So that worked. We just need to reverse the angle and definitely slow it down. So instead of 0.5, let's do 0.1, or 0.2 will be fine. And this will be negative to the left, and to the right will be negative, to the left will be positive, and therefore we can do something similar with the up and down. Cool. So for up and down, the axis will be X that we'll be dealing with. Will it? Ha. The axis should be the local X. Or maybe not. Let's see what happens. I think something wonky is gonna start happening. Because we rotate via x-axis. Yeah, that's gonna be real weird. Because with y worked, because that's what our up vector. And Yeah, that's all we're doing here. Bam and bam. So I guess this will be negative, this will be positive, and see what happens. Yeah, left to right works. Ooh, look at that. We'll do this, and this is our rotation. I'm still rotating down. Up. And nothing, 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 nothing. Vroom. Yep, this is not working as intended. Oh. Oh, I see. We're making little weird circles. Yep. Okay, so paint. Let's get paint and start visualizing. Gosh, paint looks so weird now. Another thing I haven't used in years. So when we have a camera, whoa, how about a little bit thicker? How do I change thickness? Come on. Brushes. Sure, so we've got this thing. Camera, and this is the position. This is the target. So we've got where we look there, okay? And let's just add some kind of coordinate system so that we have an idea. Let's just make it look like this and like that, okay? There we go. So when we want to start looking up and down, we've got our vector that points us in this direction. And then we want to start looking kind of, you know, if we look at our thingy, we want to start looking like this, that we want to start pointing up. That means that, oh, see you later, CPM. Thank you for hanging out. That's always appreciated. Take care. So if we want to move the camera up like this, suddenly we need to, because when we were moving left and right, let's make it blue, right? We were moving from here to look somewhere there. And it was like left and right. We were moving along this axis. So that was always unchanging no matter where we were looking at. Because we kind of want to be constrained to that x-axis. I mean y-axis. But with the red now looking up and down, if we're looking in this direction, we need to be, you know, rotating around this axis. But if we were looking suddenly like from here to there, right? The axis that we need to be constrained is somewhere here. Unlike the y-axis, which is up. So, yeah. How do we get that axis? I don't know. I mean, we can get the y-axis and kind of have the plane here. But how the hell do you get that thing on a plane? So okay, so the way I'm thinking now is that I'm gonna switch to violet, okay? So basically we have this y-axis. And we can basically make specify that we want to have a plane around here that's at the height of this, you know, that's always perpendicular to the y-axis. So now we would basically need to have something like, hey, draw me on that axis, draw me whatever on that plane, draw me something perpendicular to where I'm looking at. So if we flatten this, so we can just take some vector pointing somewhere up, right? This is its shadow. We can just point it down here, remove the y of it completely. We just, it's a 3D vector, so we remove the y, we just make it flat. It's gonna be pointing somewhere, and therefore get the 90 degree to it in that 2D plane. How do I do that? Rotate it 90 from here. Oh, okay. Figured it out. Oh, that's so silly. Sure. So if it's up, so we get the target vector, right? We normalize it. Then target dot y is 0. Wow, it already knows that I want to do that. Now, we want to do something like the let rotation axis is, well, target cross. Don't know what a cross is. Cross product or something. I don't know how that works. But I want to basically take the target vector and rotate it by the x-axis 90 degrees. And what is it? Degrees, radians, or what? Maybe we have an answer somewhere here in the original thing, because I recall there's cheat sheet, right? Core. Or maybe I can just ask Claude, right? Let's use the project Naylib, because of course I made one. When rotating vectors and Raylib, are the angle values radians or degrees? Someone tells me it'll be radians. Not the fastest answer, but I'm sure we're gonna get it. Degrees, not radians. Oh, interesting. Okay, so we just do target dot rotate by axis, and that will be 90 degrees, okay? And therefore, we can make that the new target will be rotate by this rotation axis this much. Let's see if that will work. Oh no, I changed the target Y permanently to 0. We don't want to do that. Let rotation axis is target. That should make a copy of it, right? And rotation axis Y is 0. And then we do that to it. Sure, this is gonna work a little bit better. Bum, 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 bum. Wait, what's going on? Copy it and, oh, variable. There we go. Copy and Paste. Sure. Let's see what happens. If we're gonna get anything here. Left and right works. Up and down is still weird, huh? So our angle doesn't really work. What the hell just happened? Rotating like crazy. In this direction we're rotating, in this direction we're going up. What the hell is going on? Unless at some point when we're looking down it just goes crazy, but it shouldn't go that crazy. I'm not good with vectors, that's for sure. So we can rotate it heat by 90 degrees in that angle. So if rotation axis, the length is larger than that much, right? We did it. Otherwise, not. Sure. If I don't think that's gonna do anything. Yeah, because down kind of moves on that diagonal, right? That's so weird. We'll do this, and it's even weirder. So what am I doing wrong? So I'm changing the target where I get the target, the position, where the camera is already looking. I normalize it, so that shouldn't change anything, okay? That shouldn't change absolutely anything. Then rotation axis will be the copy of it. We just remove the Y and use the Y to rotate it in direction like 90 degrees. So we have it like this, always perpendicular to the Y. And then up and down should be straightforward. Should be. But it isn't. And I wonder if it's due to this up vector. But it shouldn't be. I don't know. I'm trying to do weird stuff. I guess I should stick to 2D. Do we have a definition of that Y area or whatever? Because I would like to know a little bit more. Because that was with the camera. Do we have something else here? We have header files, FAQ, wiki. What's in wiki? Architecture. Okay. Syntax analysis, data structures. Camera 3D. Okay. Position, target, up vectors, and parameter. Not really. Um, what does the up vector on the camera 3D do? What is its purpose? In the meantime, we can keep looking. FAQ. What kind of games? Was in C? External dependencies. Okay, nothing interesting. Excuse me. Um, Examples. Games. Raylib games. Oh, look at that. All the way from 2015, 14. What the heck? Okay. I guess these are like open source games. That's what it is. Yeah, I guess these are all like open source games. Sure. But that's not what I wanted to get. Extra libraries, Raymath. Okay, it just takes you to the header file. The up vector in a camera 3D is a crucial component of the camera's orientation system. It serves several important points. Defines camera orientation. The up vector, along with the camera's position and target, defines the complete orientation of the camera in 3D space. It specifies which direction is up from the camera's perspective. Sure. Constructs view matrix. It's used in constructing the view matrix, which transforms 3D world coordinates into camera space. This matrix is essential for rendering the 3D scene from the camera's viewpoint. Prevents a camera roll. The up vector helps prevent unwanted camera roll. Without it, the camera could rotate freely around its view axis, which is often undesirable in most 3D applications. And enables stable camera rotations. When rotating the camera, the up vector ensures that the affecting perspective influences how the camera perceives and renders the 3D world, affecting things like how objects appear to tilt or align in the rendered scene. Interesting. Enables complex camera movements. The up vector allows for complex movements like camera orbiting or creating look-at behavior. Okay, so typically in a standard 3D coordinate system, the up vector is set to 0, 1, 0, representing the positive y-axis as up. However, you can modify this to achieve different camera orientation or effects. Yeah. For example, to create a camera that's tilted 45 degrees, we do up vector, this and that, normalize vector at 45 degrees. Okay. Projection. Okay. So the question is, is it okay to keep the up vector at 0, 1, 0? Even when the camera is facing somewhat down? Or do I need to calculate a new vector that's 90 degrees to the preferred forward vector? That's the question here. Okay, to keep app or even when the camera is facing somewhat downward, this approach has several advantages: simplicity, stability, and intuitive behavior. The sky is always up regardless of where we're looking. You don't need to recalculate it. However, there are some extreme angles. If your camera is looking almost straight up or straight down, keeping 0 on 0 as the up vector can lead to situations called gimbal lock. In these cases, you might need to adjust the up vector. Special effects, if you're trying to achieve a specific effect like rolling or inverting camera. Okay. Da, 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 da. Interesting. Up is cross product of forward and right. Interesting. Huh. Really? I want to use that. So that means, let's see if that fixes anything. Because I don't think it's going to fix anything. I'm going to ignore this whole weird part with ifs. Okay. Let's just leave it the way it is. So we have the rotation angle and the new target. So we said that this is the target. Okay. And camera up is basically what? Cross product forward and right. So cross product of target, that's forward, and right will be the rotation axis in my case. No idea what that's gonna produce. Things are gonna go upside down probably. Same thing here. Let's see. So left eye works. Up, ooh, was already instantly made weird stuff. What the heck? So it like, what on? What the fridge is going on? Nope. If I'll make it the opposite, that's gonna be even worse, right? Yeah, I am really confused what the hell is going on. It's upside down. Okay. Sure. So cross product is that. So that means the rotation axis could be a cross product of the target and the up vector. Y is 1 and Z is 0, right? That's what it means, I assume. And I could do the same thing here. This way we don't need any of that. Let. There we go. let rotation axis is this. Sure, let's see what happens. Oh, comma instead of colon. Vector 3. There we go. Up, up and down might reverse. But it kind of works. Kind of. Oh, because I'm still changing the camera up, right? Can I not change that? And let's see what happens. Hey, that works. I guess me calculating the cross product was wrong. Okay. I mean, that's still... Oof. I think I just broke it. Sure. Just don't go more than some down. But for now, that should be it. So... Hell yeah. That works. So we've got that going. I just need to reverse those. And that will be it. So that means that when I run it, I can do left, right, up, down, no problem. Whoa. I see when I'm moving up and down. Now I just need to do one thing. So, So now when I'm changing the location, I need to reapply the targets and stuff. Okay. Sure. So let's do... So if this or that, so basically when any of those is pressed, then I have to do something. So it'll be let alt position is camera position, or maybe not even that. Let target direction or target vector is just that. We have the vector. We update the position. Yeah, and target is position plus the target. That's that. Sure. That means I need to have the same thing for all of them, which is super ugly, but I'll live with it for now. So save that, run it, and that means that we should be able to move left, right, down, and up, and separately move around, okay? The only thing now would be to actually make it that when I'm moving left and right, it's depending on where I'm looking, okay? So let's change that. So D will be to the left. So I basically need to get the left vector. And so I have the target where I'm looking at. So for left and right. Yeah, let's do it as simple, like depending on where the camera is looking. So let's left vector is cross product of target and the up, right? That will be left. Left vector dot normalize times 0.1. Okay, let's see what's that gonna be like. left. Okay, left still works like left. What now? Ah, I'm doing the right goes where it's supposed to, left doesn't. Okay, cool. I guess I was doing D is to the right, sorry. So we're gonna do the same thing here. Yeah. Bam. We just do times negative. And when we run it, it should be all good. Left, right goes. And now look at that. I can move left and right. Cool. Okay. So now I would like W to actually not go up and down. I would like it to go forward and backwards. So for that, we have the target vector. And position will be the target vector normalize times this. And this will be negative. And we should be moved left, right, forward, backwards. And with the other arrow, we'll be moving the other way around. Left, right. And look at that. We can move forward and fly. Where's the... Oh, here. Sure. So now let's change the FOV to 85. It's gonna look weird or normal. Because I'm kind of used to 85. Oh yeah, no, that's better. You can see a little bit more how it's stretching. Cool. So now it's just space to go up and C to go down, I guess. Or I could do Q, R, and R. Q and E. Let's just do space for down. I mean up. So F is key down. Space. Okay. Target vector is this. So then we're gonna have the let up vector. It'll be cross product of what? Because we need left vector and then we can get a cross product of up vector. Left vector, right? We got this guy. That's our left vector. So let up vector now will be cross product of left and target. And we just add the up vector. And set the new target, I guess. Let's see if that space actually works now. Okay, we move here. Space goes up and space goes up. Look at that. Up no matter what we're looking at. Perfect. Okay, this is pretty good. I must say, this is pretty good. So that means we can now do F is key down. Do we have CTRL? Control? Left control, sure. And then we're gonna basically have the same thing. Copy paste. The only thing is that we have negative for the up vector for the position. That means we should have pretty decent control. Up, down. And I mean, we can just go fly. Whoa, what just happened? Oh, that's our problematic other thing that I don't feel like dealing with right now. But we can move like this and out. And basically, yeah, we have full controls of normal, what I would be used to with something like Unreal Engine or something. It's just arrows instead of mouse. Cool. So let me copy that part of the code, okay? And let's see if AI can figure out how to fix that problem when we move around with Z. Okay. I have the following code for moving the camera. ASD plus space plus control. And rotating it with arrows. Up, down, left, right. Okay. And this will be nim. We paste it here. Now I have a problem where when I look straight up or down, it starts to go crazy. How can I solve the issue? I'm looking for a commonly used solution. Because, you know, this is not a first time somebody encounters this problem. This is like very, you know, normal thing. It has a name, gimbal lock. Where two axes of rotation align, causing a loss of 1 degree of freedom. This is common on camera systems, especially when looking straight up or down. Use quaternions for rotation instead of Euler angles. Hell no. Or implement a pitch limit to prevent the camera from looking exactly straight up or down. Here's how you can modify your code to implement these solutions. Camera rotation with this. Angle Y, X. Oh, okay. Oh, I just pre-calculate those. Clamp it. Ugh, quaternion from Euler. Ouch. Ugh. Ow. I mean, that kind of makes sense because in here, we basically have camera angle X as in, I guess, up and down, and Y, how we're rotating around, because we don't need any other angle. And because of that, we shouldn't need to worry about anything here. It kind of makes sense. Target position. Huh, I am curious about this. So this is all placed in a new procedure, right? So let's kind of try that. I am curious. I am actually genuinely curious. So what did I just copy? Oh, those. So we have the camera set up, right? We're just gonna make it that we also have our angle X, Y, and pitch limit, which can be a constant, okay? Deg to rad. Deg to rad. Where did I get deg to rad from? Yeah, there's no deck to rad. Cost deck to rad is this. Do we have pi? Import std/math. Do we have that? Now pi works. Deg to rad now exists. Or we can say it's 89. Whoa, what just happened? Bam. Okay, we solved this issue. So that's that. Now we have update our camera. So we can just replace this whole ugly thing with, I mean, no, not all of it. Just this. Just this, we would be able to replace it with this. And then clamp the vertical angle to prevent looking. Okay. Create rotation quaternion, rotation matrix. Ugh. Forward. Update the camera and camera up vector from crazy stuff. I guess. Let's see if this actually compiles. Ha! Has no type or is ambiguous. And as in quaternion from Euler. Dot. Rotate by quaternion. What can we do with the quaternion? Do we wait? We can use those fancy docs, right? Ray math. Do we have anything with quaternion? Rotate by quaternion, which takes vector and quaternion. Okay. Scale it. Spherical linear interpolation between two quaternions. That's interesting. Subtract. To axis angle. Get a rotation angle, an axis for a given quaternion. Nope. It's all to Euler. Okay. How about from Euler? To matrix. Transform. There's a bunch of stuff in templates. Divide. From Euler. Give pitch, y'all. Roll. And we get quaternion. Okay. From Euler. And then what? Quaternion to matrix. We should be able to do that. To matrix. Quaternion. Okay. To matrix. So that kind of makes sense now. This is a quaternion matrix. Matrix and M8, M9, M10, all that stuff. What? Where did that come? Where does that come from? Okay, it has a bunch of them. Go figure. Bum 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 bum. Let's see what happens. I'm running out of steam, but nonetheless, we're getting somewhere. And that somewhere is nothing's displaying. No. So we're updating this camera angle, right? We started with 0 for everything. Really? Sure, we started from 0 for everything. We have quaternion matrix. We do this bunch of stuff. Yeah, I'm sure it's possible. But for now, I'm just gonna stick to my solution because I understand it. It's stupid simple and unoptimized, but it works, right? Can move left and right and all that stuff. And that's still just an example. And I'm sure if we have access to those quaternions and all this stuff, we could actually easily, you know, with just some thinking or whatever, figure out how to actually get it working. So yeah, that's that. Yeah, we've got 3D. I just want to see one of their 3D examples, probably with a free camera or something. Examples. And what's this one? 3D camera first person. Okay, so you can look left and right. We can walk. Jump doesn't work. But okay, space. Nope. Left control doesn't work. Whoa. What the hell did just happen? What? It just closed the thing? Okay, so this works. Camera mode 1. Free. Okay, this is free where we can fly around and space goes up and down. As in that. Ooh, wow. Okay, so in a free mode, this freaks out as well. They didn't make it nice. Too bad. Yeah, and the target is always few ahead. So that's probably the solution that's similar to what I did. Okay. Number 2 is first person. So that means we just move around. Okay. And the space will need to be, I mean, the jump will need to be simulated a different way. Okay. Sure. That's 100% usable. We can just move and rotate, I guess. Oh no, because this is how it's being controlled with the mouse and stuff. Then we've got the thing that when we rotate up around something. Okay, that's cool. So we can plop it here or something and just move around it, look around it. Okay. And number 4 is orbital. Okay, it just orbits around that thingy that we did. Like, we plop it here and it's gonna just orbit automatically because why not? Huh. And camera projection, we have orthogonal, okay. Or this, that's that. Sure. Okay, that's a good example. All right. Textures, so that will be probably the next time, right? When we figure out how to logo Raylib this is a texture, okay? So let's just take a peek. in a window, texture, load texture. Okay, that's it. Just point it to something. That's simple enough. Image drawing. We're drawing only one texture from various images composed. Source images have been cropped, scaled, flipped, and copied over the other. Okay, I see. So this is good. So that means we can just cat load image, crop it, flip horizontal, image resize, then gets the parrots, blah blah, draw onto each other, upload image from RAM. Doesn't mean that it's available for the, what do you call it? For the GPU? Upload image. Interesting. And then we load the font, image draw text. Okay. Huh. This is interesting. Oops. This is interesting that, you know, this parrots and whatever, it's also being drawn by the thing. Interesting. Yeah, image loading. Image generation. Okay. Mouse left button to cycle procedural textures. Okay, cool. So this is really cool that we can actually draw those buffers, because that opens up a lot of possibilities, especially with shaders. Image processing. Oh, look at that cute little menu. Yep. Oh, nice blur. Okay. Image text, sure. To image. This is a texture loaded from an image. So retrieve image data from texture. Load image from texture. Images are loaded in CPU memory, RAM. Textures are loaded in GPU memory. Oh, okay, I see. So we basically have a type image and we have type texture. Load texture from image. Interesting. Oh, and I guess for textures, we upload them to, they go to GPU memory, and therefore we can do stuff on them. So upload image data from CPU memory. Oh, unload. Okay. Sure. Okay, texture from retrieved image data. Load image from texture. Okay. So yeah, this is really nice because that means we can just basically load up. Let's say we're making some kind of tile map. We can make something that loads a bunch of tile maps, arranges them around, defines a config, and then when we have the full texture, uploads it to the GPU. Something that various games do, like modded Minecraft does that, or Factorio, and I'm sure a million other games. Cool. Check texture generated by code and a raw image loading. Huh. Load raw image. Pixel format compressed. Oh, okay. So this is where you can actually do more fancy stuff. Particles blending. And patch drawing. Look at that. To stretch or shrink the end patches. Okay, makes sense. Yep. Okay. That's simple. So that means we have something specific here? No, we just make our own end patch info. So that's built in. Okay. So we have a few basics, and then we could easily make our own abstractions, really easy. Spread animation. Okay. There we go. Do we need to do it ourselves, or do we have something that controls an animation? No, this is all ourselves. Okay. But doable. Sprite button. Lovely. Ugh, horrible sounds. Another sprite. Oof. That was loud, sorry. Yeah, we've got the sound, so that's cool. Yeah, but all the animations are by hand. Therefore, we could kind of make our constructs for sprites that decide should I which frame to render and draw at a specific time. So I guess there will be a lot of overhead. SVG loading. Oh, well, it loaded, but microscopic. Bunny mark. How much can we get out of browser? Down to 30 FPS I want to go. Okay. It's gonna be going down faster and faster. Oh, 50,000. That's the limit. Really. Batch draw call 7. Interesting. So I get 47 FPS. 47 at 50,000. What if I'm gonna... Oh. Maybe I can somewhat easily recreate that. This will be the last thing today. I'm gonna recreate the bunny stuff and see how much we can push. Nim isn't the fastest, but it isn't the slowest either. So let's put it aside and recreate. So all that gone. Max bunnies, no such limit for us. Max batch elements. This is the maximum amount of elements quads per batch. This value is defined in RLGL module. Wait, we can actually define our own meshes and stuff in quads? That'll be interesting. So for now, we have those, but let's define max bunnies and max batch elements, okay? And then we can define type bunny, which will be an object. Vector to position, speed is vector 2, and color is color. Sure. So we've got an equivalent. And now what? We have screen width and height. Initialize the thing, so we've got all that. And load bunny texture. We need to download that. But for now, game setup. That'll be it. We get rid of all the camera stuff. We are not using it now. So let bunny texture is load texture. A Wabbit alpha. So let's go grab it. Does it have a link to the actual source code? There we go. Resources. Wabbit alpha. So download. I presume that the resources will be for not the source, but the actual thing that's running. So new folder. And wait, what did I do there? Where did I save it? Did I start saving it? Oh, I downloaded it. Okay. Makes sense. Okay. We've got our Wabbit Alpha here. So that means that this should work. Okay. That's our bunny texture. And then we need a... Oh, so we pre-allocate the number for bunnies already. Huh. Sure. Maybe I'm just gonna go sequence for now. We'll see if that's gonna change anything. So let's do var for bunnies. New sequence. Sure, of max bunnies. Why not? And bunnies count is 0. So in our game loop, what do? On left mouse button, right? Let's get rid of all this stuff. F is mouse button down, left. Okay. Then we just create more bunnies for 100 of them. We basically do what? If it's less than this. No. If bunnies count is larger or equal to max bunnies, just exit the loop. Come on. This is more optimized. Otherwise, we basically need to create a new bunny, right? Let bunny is... Oh, we just will be updating them. Oof. Okay. For bunny is bunny, okay. Bunny dot position. It'll be get mouse position. So let mouse position is this, okay? This is gonna be a little bit faster. Then we're gonna do speed X and speed Y. Is it really get random value? I don't think so. So let's do import standard random, I guess. Let's just search for it. New tab, name lang documentation. Standard library, and we had this random thing somewhere. Random. There we go. There was a manual here, right? Randomize. Call randomize once to initialize the default random number generator. So here during initialization, we're gonna call it. Randomize. There we go. And then we have random and specify from what to what. So we just do random from negative 250 to 50. Random from negative 250 to 250. There we go. Beautiful. Now we just need another one, which is exactly the same. Now it just doesn't like that we're doing that. And we just do the same thing here. Now it's happy. I don't know that's the fastest, but it should work. Okay. So we've got the speed for X and Y, and then will be color, which will be random values between those. Sure. Good enough for me. Okay. R, G, and B, and of course the A. Alrighty. Is declared but not used. Left vector. What the heck? That's some old stuff. Sure. Okay. And this way we increase the bunnies count. Okay. Cool. Oh, and we need to add it to the bunnies.add bunny. Okay. There we go. And when we do new sequence, I need to check that. Sequence utils. Where is it? Sequence utils. New sequence. Okay. Length, right? Where did I go? New sequence. First, creating new sequences of type T. Bum, 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 bum. What the hell am I missing? New sequence. So this is in system. So it is that. So we have new sequence. Create new sequence of type with length. Note that the sequence will be filled with zeroed entries. After the creation of the sequence, you should assign entries to the sequence instead of adding them. Okay, that's what it is. It pre-fills them with zeros. So, because of that, we're not doing that. So we just do bunnies count this and that. Okay, so we're not doing this because we already have bunnies created. Bunnies count, and we just update those. Okay. What the heck did I just do? Now we're good. Okay. Cool. Sure. So then we have update the bunnies. So after we created those that we needed through clicking from 0 to bunnies count. Okay. Not including it. Okay, so bunny's position we increase by the speed. Okay, that's good. Then what? If position is this, sure. How about I already have screen width and screen height. I don't want to get it. If bunnies I position.x plus the texture width by 2. This is doing calculation everywhere. I don't like it. Or okay. No more ores. What the hell's going on? Have this or this. Then if that's the case, we're gonna do speed X reverse. Now we're going the other direction. And is position Y plus this and that. So let's do the other thing. I don't want to have that recalculate every time because we have this. So let's do constant bunny text with half. Bam. And bam. Okay. This way we've got it pre-calculated. And it's a not constant. It's let, but it should be already much better. There's some random 40 added to it. So I guess that's the what? Go figure. Random 40. Okay, we're good with that. So then we'll be basically drawing them. And how are we drawing them? Draw texture. So note, when internal batch buffer limit is reached, a draw call is launched, a buffer starts being filled again. Before issuing a draw call, updated vertex data from internal CPU buffer is sent to GPU. Process of sending data is costly, and it could happen that GPU data has not been completely processed for drawing while new data is tried to be sent. It could generate a stall and consequently a frame drop, limiting the number of drawn bunnies. Okay, sure. So we just click the back, clear the background. We're gonna do for all the bunnies that we're displaying. Let's draw the texture. Bunny texture. The bunny position X and Y. And color. Okay. And that's it. And then we're just gonna do draw rectangle. This black text, bunny's number, bunny's draw calls, and draw the FPS. Text format. Okay, let's ignore that part. We're just gonna do this, even though this is kind of unhappy about it. But I don't feel like rechecking how to do the whole C-string stuff. Okay, this is gonna work. Hopefully. Let's see if that's gonna run. Because there are lots of variables here. I don't know, for example, the texture will copy properly. Oh, there we go. Bash draw calls, it's with commas. Bunnies, 600. Okay, let me just fix those things. The number goes here. Okay. Batch draw calls is bunnies count divided by max batch elements. I see. Divide. Okay. And not that. There we go. This way we'll have a nice normal number. Okay. Click. Click. 60 FPS. continue. Okay, this is getting better. We reached 50,000 again, 7 draw calls, but now we got 60 FPS and actually higher resolution than was in the browser. So that's much better. So now let's speed the number of creation times 10. Okay. So it'll be 1,000 per frame to be created. And let's make the limit. Where did we set the limit? Maximum bunnies. 5 million. Shouldn't be too much RAM, right? 5 million, not really. Just bam. So we create, look at that. We get to 200,000 and we're already dropped to 33 frames per second. 25 draw calls. Huh. That was faster than I expected. And bam. And we've got that much. And if we want to go to 10 FPS, it will be harder and harder because we're making this more and more slowly. I guess up to 50,000. I mean 500,000. Come on. Okay. Could probably get to 650,000, which is 80 draw calls. And that's already down to 10 FPS, huh? What is using? Because I don't think the processor is here a problem. Task manager. Memory is being used by nothing. CPU, nothing. Can I add GPU to this list? There we go. GPU. What is using it? Visual Studio Code. The basic window is using 10% of GPU and 10% of CPU. So we're hitting some kind of strange limit. Okay. For the GPU, we're not doing much. Okay. So max batch elements, where are we using it? Are we using it anywhere other than calculation? No, we're just showing it. So I guess internally it just works that way. Interesting. Because now I'm thinking, do I have anything to kind of improve performance here? Because we have a sequence. What if we replace it with an array? 100% possible, right? Because we're already defining it as the thing. So array of integer or what, max bunnies? How many elements? Wait a moment. I need a tutorial, not again. I'm starting to forget things. Standard library or manual? No. Let's head to the So this thing, we can go to documentation, part 1, arrays. So from 0 to 5, right? Okay, just like that. That's a type. And then we can just create it here. But what if I wanted pre-filled? I mean, it does come pre-filled, right? I'd assume so. So from 0 to max bunnies. Sure. Will that work? No generic parameter allowed for bunnies. That is not a generic parameter. What the heck? Ay, ay, ay. Type bunnies array. There we go. Sure. Let's see if this even initializes. Oral tab expected. Really? 54. Ordinal type. So I guess we can't do those fancy things. Let's retry it. No window. Huh? It doesn't start up. That's not great. How do I initialize an array? I'd assume that it's gonna just get initialized. Returns an array length and all that stuff. I mean, it should work. I don't think that's gonna change anything either. So, C string from nonce. These are just warnings, okay? Ordered error in the future. No, it will become an error, but that's not a problem here. And import shouldn't break it either, for like stop it from working. Yeah, a moment, and then it breaks. So for some reason, it really doesn't like the array. Let's reduce the size of the array. That's not a thing either. So what on earth am I doing wrong? This tutorial kind of sucks. Arrays. Yeah. So this won't work. We will need to specify it here. The correct way to declare an empty array, which will be filled later, is to give its length and type without providing values. Okay. So I guess I need to find a thing to fill an array. I mean, there will be an option of turning a sequence into an array, right? So I could, in theory, this gets back to 5 million. Okay. So in theory, I could just do, none of this. Or sure, bunny's array. Is um what the hell am I trying to do? Because I recall there was a nice way to fill an array or something. Fill. And array. Search for array, and we have only those. Fill. Assigns value to all elements of the slice. Container. To open array. No, this must be somewhere. We got system. Got array. Generate type to construct fixed length arrays. Why am I stumbling over that simple thing? How do I create an array in nim that has all of its element ready assigned 0? Oh, I can use default. That's it. All right, that makes sense. Default of Bonnie's array. Ha! Will that run now? No, it won't. The heck? Why does it work as a sequence but doesn't work as an array? This is so strange. Extra size? Hmm. It's as if operating system just stops it. MC-R source slash this. Blah, blah. Execution of an external program failed. That's the only error we're getting. Wow. Oh, I know, because Array tries to Elemental Magic's card game says hello. How goes it? It goes well. Nearly finished the stream. So I think it's because an array tries to put itself on the, what do you call it? On a stack for some reason, but I don't think that should be a case. So I really don't know. Sequence of bunny, max bunnies. I mean, new sequence. There we go. That worked. That's the one where we can, you know, just make a lot of them, right? Yeah. But what if I'm gonna run it with the release? Was it the release? Ba -ba -da -ba -da -ba -da. This thing. Okay, that's thinking more. Okay. So let's actually build it in release mode for a change. If that's gonna even build. Okay, not built. Okay, that's good. Maybe that's gonna run a little bit better. Oh, it does run better. To get to 30 FPS. Wow. That means we can get to the million. To a million. There we go. Whole million. Oh, the release mode is so much better. Woo. Okay, that's a big success. Do they have like a rotation or something? Bunny's position, all that. And draw texture. Do we have anything else in there to provide? What can we provide in draw texture? Doesn't want to open the draw texture for some reason. Why? It was working a while ago. Let's restart it. Okay. New Nimlang server. Nice. Although I'll probably rebuild it from scratch. Draw texture. So the position X and Y. Although we could just use position, and that could be a little bit better probably. We've got a tint, or we could add rotation. rotation. There we go. And even scale and everything. Sure. So that means that we could also track 2 extra things. Or at least just rotation. Or start with a scale too. Why not? Funny. It'll be rotation and scale. Okay. So when we create them, rotation, sure, and scale. Okay, that's gonna be more fun. So if that's the case, that means we can, when drawing, here. Just that. That's first thing. Okay, that's the position. But then we're gonna do rotation and scale. So that's good. That should already be a significant difference. For sure in performance too. Okay. Look at that. It's just so many more. And because of that, all that extra data, which seems like it might be actually CPU in that case, not the GPU. What is, 48 draw calls for the GPU? That's nothing. This must be straight up iterating over everything. And kind of probably setting all the data. Because look at that. This is really bad frame rate. And additionally, because we iterate over them here, then we iterate over them there. Ugh. Yuck. So that was the position plus speed and rotation and scale. We leave the same. Okay. So run it, and they should all slightly rotate now as well. This is a very slight rotation. What the heck? There we go. Now they're kind of rotating. Slowly, but they're rotating. Oops. So that means, yeah, frame rate is getting a big hit. I really wonder what is the cause here. I mean, this is not a lot of code to run. Something tells me this is the problematic part. And I guess I could kind of try to profile it. But no, thank you. I'm not gonna be doing anything near it in the first place. But so far, I'm really happy that something like that is possible. I wonder how to also do something like tile maps. Because the draw texture, where was it? Draw texture, okay. We have the position X and Y, all that stuff. Draw a part of a texture defined by a rectangle. So that's another thing. We could just draw a part of a texture. And I wonder if that would make it suddenly possible where we can, do a bunch more stuff. Like, if it's still a one draw call, if we print parts of the same texture multiple times, because that means that we can have a tile map that is, you know, just an atlas of various things and just print parts of it within a single draw call, which is, you know, good performance. The other thing is, can we create our own meshes? Because I really would like to be able to create my own meshes. So models, animation, billboard, cubic map. What is cubic map? Don't know. Camera, texture 2D cubic map, mesh, generate mesh cubic map. Oh, but that's something built in, but there's an object mesh. Doesn't mean that we can make our own. Look at that, first person maze. So is that made of boxes or do we actually generate something? Map. Generate mesh cubic map. Okay, so that's basically something. Geometric shapes. Draw cube. Okay, there's draw sphere, draw cylinder, and capsule, and grid. Okay, all right, that's good. Good to know that this actually exists. And mesh generation, look at that. Mouse left button to cycle procedural models. Okay, so we can generate meshes. Load model from mesh. Generate mesh plane. Okay, mesh custom. Look at that. If we can generate our meshes, that means that we could actually make some kind of interesting... I mean, first of all, if we can generate meshes, that means we can make a large tile maps. Because if you make a tile map out of a mesh, you can have nice blending between things. You know, think of RimWorld. It straight up uses because meshes, because you can see that how between some things there's blending, between some other things there's no blending, and some stuff around it. So if we could do that and still print it in 2D, that would be great. And then otherwise, if this is relatively performant, that means we can also make voxel things. That would be fun too. Although something tells me it would probably break my head loading voxel, but this is loading static vox files. So that's kind of meh. But hell yeah. Waving cubes and whatnot. Yep. Bunch of stuff. Alright. And a height map is built in too. Oh, that's good. Load texture for image. Generate mesh height map. There we go. Okay, I'm starting to see some potential in this. It might be possible to make something. Too bad there's no like UI tutorial. Because I recall they mentioned that there's UI stuff, right? Rage UI. That's immediate UI, I believe, right? Mm-hmm. Okay. Code sample. Rage UI. Does our Naylib support that? That's the question. Come on. Naylib. Raylib, math, RLGL, reassigns? Oh. Welcome back, CPN. Based on what I'm seeing, Raylib is basically a game engine. I wouldn't call it an engine. Engine would be when it would actually have things like entity management for you or actual resource management. Here you need to start doing stuff, and that will be probably still just game framework. Engine is when it does a lot more for you. So definitely game library. But pretty hacky, so I'm starting to enjoy it a little bit. Smooth animation transitions and memory. Oh, come on, I wanted UI. Too bad. But we can probably make our own UI, I guess. What is RLGL? Okay, directly dealing with frame buffers and okay. What do we have here? Buffer count, bind shader buffer. Okay, so we have some draw level stuff. Disable layer mode, draw render batch. Draw render batch data. What is batch data? Buffer count, number of vertex buffers, multi-buffering support, current buffer, vertex buffer, draws. No, that's just okay. That's just display the debug info. And draw vertex array. Draw vertex array currently active VAO. Vertex array O. Okay. So we've got some low level stuff, but RLGL. Do we have some more info on it? RLGL, what is this? What is it exactly? Multi-OpenGL abstraction layer with an immediate mode style API. Okay, so this is just OpenGL. But that means it's supported everywhere, right? To some extent. Okay, Raymath, audio, GUI, PNG, and res as in resources, right? File format for package resources. I want to see if there is something with this UI. Because it suggests that you do all this. Let me see if I have button available or something. Because Raylib nim button. Oh gosh, mouse buttons everywhere. Gamepad buttons. Yeah, it'll be all about gamepad buttons, right? Because we're already at 60. Yeah. Yep. So not here. Raymath. Do we have Ray GUI? I'll save it and no. Cannot open file. So Ray GUI does not exist. Too bad. Too bad. All right. We should be able to make something with that. I'll think what we can make. Some simple game maybe next stream. Something real simple, but I'll think about it. And I'm open for suggestions, by the way. So leave suggestions in comments. And I'll be finishing for now because it's real late. And wow, my visualizations can go away. But hey, I'm excited, and I'm really excited about this working. And as that is so easy to implement. So that's awesome. All right, so CPN says he has no suggestions. I'm sure I'll come up with something real simple. Don't know yet. For sure 2D. I'm not delving into 3D yet. Not with this kind of engine, because that means that it will be lots of dealing with math, and that's the one thing I'm trying to avoid, and that's the one thing that usually kept me into game engines. I can avoid math. Yeah, so that will be, we'll see next Monday, because I need to finish the series with the Unreal and the NIM for Unreal Engine. But we'll see. For now, I really enjoyed Raylib, and yeah, this might be stepping stone towards the NIM and Godot, which probably will be a lot of fun. All right, so I'm finishing for today. Again, thank you for hanging out, CPN. It was a real pleasure. And for anybody else, if you like the content, consider subscribing, consider liking the video, and if you're watching on Twitch, consider following. So for everyone, have a great night or have a great morning, whichever it is for you. See ya.